on governance on transboundary aquifers, strengthening cooperation, session number 11. And I would like it first to thank you all the participants and also the panelists that are for this new session. And I hope it will be very dynamic. All questions you can address in, so and that will be a reply, we hope, at the end of the session. And now I would like it to present Alberto Manganelli, Executive Director of the Regional Center for Groundwater Management in Latin America and the Caribbean, SEREGAS, that he will be the chair of these sessions. And I would like to give him the floor. Thank you very much, Alberto.
Okay, thank you, Alberto. Good morning and good afternoon, depending on your region. Well, we are in session 11 under the topic of governance of TBAs, strengthening cooperation, and we have 9 relevant speakers who will present to us their work about this important issue from different approaches. I will make a very brief introduction of each speaker, but all of them have an extensive curriculum and a vast experience in this matter. So we will surely learn a lot through their presentations. I want to remind the speakers that you have 15 minutes to make your presentation, and I will let you know where there is 1 minute left to finish your presentation. And now, okay, we go to the first presentation corresponding to Mohamedou Babasai, who is a senior hydrogeologist of the Sahara and Sahel Observatory, and his presentation is entitled Conjunctive Management of Water Resources and Governance of Transboundary Aquifer of Ulimeden Taudeni Tanesruft. So the floor is yours.
Thank you, Mr. Chair. I'm going to share my PowerPoint. Can you see it?
Not yet.
Coming. Is it okay now, I think?
It's starting.
Yes.
Yes. If you can put full screen, please. Or presentation mode.
In presentation mode. Yeah, just
yes. Okay, perfect.
Okay. So, yeah. Yeah. So I'm going to make the presentation in French. I think the translation is there, so there's no problem. As you mentioned, Mr. Chair, my presentation will be about the conjunctive management of water resources and governance of transboundary aquifers of Ulimeden Taudni Tanesruft in Western Africa. Okay, and this project is implemented by four institutions, but we as OSS, we are in charge of one of the components. For those who don't know Sahara and Sahel Observatory, so je vais juste préciser en fait que c'est une organisation.
It is an international organization with 26 members from North Africa, West Africa, Central Africa, and Eastern Africa. We also have 7 members from the global North: Germany, Belgium, Canada, France, Italy, Luxembourg, and Switzerland. 8 regional African organizations, 2 partner organizations, the FAO and the UNCCD, and 3 NGO members. Now, the aquifer system in Ilomeden, Taodeni, Tanit Ruft, as you see here, it overlaps with the Niger Basin. And so what is really important to understand here is that we want to set up conjunctive management. So that means concerted management of groundwater and surface water. So as you can see here, the Niger River is going through both the aquifers, and you see the relevant countries that it is going through. And so we wish to provide a model of our knowledge of these aquifers. And with that knowledge of the Niger River, we would like to end up with conjunctive management of this shared resource. Now, the aim of the project is to improve the management, governance, and conservation of resources based on the knowledge of the Niger Basin and the Ilomeden, Taodeni, Tanit Zuft aquifers in order to support IWRM for the benefit of communities and ecosystem resilience. Now, as I was saying, it is financed by the GEF and implemented by 2 agencies, UNDP and UNEP. And then there are agencies for implementation: the Niger Basin Authority, UNIDO, the SSO, the Sahara and Sahel Observatory, and UNESCO. And each of these entities is in charge of one or the other component. Now, the project is made up of these 4 different components. First of all, the promotion of conjunctive management of groundwater and surface water. Second, the sharing of duties and benefits with local communities and civil society for these resources, including groundwater. Third, strengthening industrial capacity in terms of environmental responsibilities as well as social responsibilities. And fourth, strengthening capacity and the involvement of stakeholders for the management of the ecosystems of the Niger River. Now, we started by improving our knowledge of the aquifer system. So there was an initial study that was conducted by the SSO for a number of countries. And then the project was extended to Benin, parts of Algeria, Mauritania, and Burkina Faso. And so what you see here is the data that we collected. And here you see the data in red. And so we basically tried to understand the geometry of the aquifer to really conceptualize the aquifer system. And so you see the lithostratigraphical data here, one that goes from west to east, from the Niger River to Zinder. And so here you see the two main layers, so the two aquifers. And so without going into details, you see the various layers, including the deepest layer. And then, of course, there are the other aquifers as well. Now, we simplified this system with two main layers. And so we had to take a look at the abstraction history for various countries. And so you see that on this figure, you see the evolution over time of abstraction from the 70s right up to 2020. And so you see that we are under 200 million abstractions cubic meters per year. Now, we also sought to update a database that we already had with data from new countries and more recent data. And so we collected recent data to formulate this piezometric time series. And so that data collection activity was undertaken in Burkina Faso. That is what you see here. So there's some interesting time series data here, which is important to the study and to the modeling. Now, in terms of model calibration, now we used a specific software in order to understand the aquifer's characteristics and understand its hydrodynamic behavior. And so here you see the model calibration on the left. And you can see that the data is accurately represented. And then on the right, you see the calculated drawdowns in 2020, which reach 20 meters. Now, this table gives you an overview. The most important aspect to understand are the exchanges between the Niger basin and the others in all the various layers. And so as part of this system, you can see that there is a greater deal of water going towards the river. So the contribution of aquifer systems to the Niger River, and particularly in the topmost layer, you see 7 cubic meters per second going in that direction. Because it does depend on where we are measuring. But here we're really measuring the flow between the aquifer systems and the Niger River. So whether it is the Taoudini or the Ilomenden, we see that it is the aquifers contributing to the Niger. Now, we also led a cross-border diagnostic analysis, which helped us improve the model by taking into account provisional simulations. Now, we had identified a number of trans-border issues, and I will let my colleague Abdul Kader, who is a coordinator for the water department at the SSO and who also coordinated this project from its early days, be it in the first phase or the second phase. I'm going to invite my colleague to continue this presentation and to give us a sense of the work that was done for components 1 to 4 and our consultations for the good governance of these shared resources. Ladies and gentlemen, good afternoon. I'm going to take over from my colleague. Now, so we set up this trans-border diagnostic analysis. Now, we were looking to get a better understanding of the threats to our resources and how conjunctive management could contribute. Now we have the Niger Basin Authority, which is composed of 9 member countries that you see on the top left for the entire basin. Now, it already adopted this approach, which helped adopt the Strategic Action Program for Sustainable Development. So as you can see, there were 2 aims, and it also led to a number of strategic actions. Now, on the other side, at the bottom, you see an initial study, and the idea here was to make sure that the Taudini Tannis-Ruft system could benefit from a certain number of initiatives, taking into account the threats to these groundwater resources. And so the idea is that altogether, the result gives us what you see on the right, an integrated conjunctive approach to groundwater and surface water. And so we saw
1 minute.
that this was a particularly crucial approach. Now, to run this trans-border analysis was essential to arrive at a conjunctive management of these resources. And so here we see the validation of the TDA in Benin, Burkina Faso, Mauritania. And so we had a strategic action plan that led to the setting up of 6 pilots and a number of themes that were identified, as well as challenges for the effective management of groundwater. And so the 5 themes: effective groundwater management, the reduction of high groundwater mineralization because of fluorides, combating pollution from various sources, mining, domestic, agricultural, industrial, adaptation to climate extremes, the integrated management and planning of surface water and groundwater. And so, as we saw in the model or with the TDA, it wasn't just a question of quantity, but also of quality. And so these are considerations that need to be taken into account on how we can have an approach that is more competitive and ecologically minded. And so, and and the issue of waste, be it from mining or other activities, was important.
And here an example of that. This is where you have the lake system that flows into the river, and the organization has implemented a number of technical solutions. And this is being rolled out on a number of other hotspots as well. And this is something that is really important to me. That's another example to illustrate how in 2014 countries met in Abuja to agree on having a management framework for groundwater. The idea was that even though those waters are invisible, they wanted to make them visible. So you have a number of ministers and ambassadors on the pictures, and everyone signed on this statement to create a joint management scheme for transport groundwater. And it's kind of obvious, really, that you really need a tool to be able to coordinate this management between countries. And this is why there's a platform that's being currently fed by the products emerging from those projects, where we can have the different information taken together on the platform of the project. Thank you.
Okay, thank you. Okay, thank you, Mohamedou and colleague. It's obviously a great job you are developed, and I think it's a great challenge to carry out a cross-border project that involves 11 countries. The importance of the ongoing project to support good governance of water resources in the region has become very clear to us, and also the importance of the international cooperation to reach the appropriate results. Thank you again. Well, the next presentation corresponds to Karen Wilholtz, who is principal researcher at the International Water Management Institute, where heads up the groundwater program and coordinates the groundwater solutions initiatives for policy and practice. The presentation is entitled Transboundary Aquifer Governance in the Context of Transfrontier Conservation Areas, an Opportunity for Synergy in the Southern African Development Community. Karen, the floor is yours.
Thank you very much, Mr. Chair. And thank you for the opportunity, and thanks to the organizers. It's a great pleasure to be here and to be part of this session. And thanks for the introduction. I think I can go straight into my presentation, as you already introduced me, so thanks a lot for that. First, I would like to give credits to our collaborating partners and our funders. So in this project, we're working with the CASA Secretariat, which is a secretariat overseeing this transfrontier conservation area in the SADC region. And we're also working with the Peace Parks Foundation that are working in close cooperation with CASA. And the project is funded under the USAID through the Resilient Waters Program. And this work is, of course, not only my work, but jointly with a lot of other partners. Thanks. Outline here is, first I'll just briefly describe what IMI has been doing in the region so far on transboundary aquifers and transboundary water systems. And I like to emphasize the water systems and not just aquifers, because I think it's coming through quite clearly in this conference that we need to integrate across the various water sources. And then I'll go more into the specifics of the project and what we have sort of gained over the last, it's actually only a year that we've been working on the project so far, and then some outlook in terms of governance implications and so on. So as you can see here, this is the Southern Africa region. And I've indicated 4 different systems here that we've been working on over the last, or since about 2015. We started with the Ramotswa system. You can see to the left here. It's a very small transboundary aquifer. It's not more than, I think, 1,000 or 2,000 square kilometers. It cuts across Botswana and South Africa. And we completed a transboundary diagnostic analysis as well as a strategic action plan related to this aquifer, which has issues of some contamination in urban areas spilling over to peri-urban areas. We also worked on the Tuli Karoo system, which is shared between Botswana, Zimbabwe, and South Africa, and the Shura Basin, which is at the lower end of the Zambezi watercourse. And then the one that we're talking about in this particular session, the CASA Transfrontier Conservation Area, or the CASA TFCA. CASA stands for the Kavango Zambezi. So it's the intersection between the larger river of the Kavango River and the Zambezi River. And it's a quite large area, as you can see, and it spans a lot of area, both in terms of countries, in terms of river basins, and also transboundary aquifers. And I'll come back to the details around that. Here you can see the data, and you can see a little clearer map to the right here, where I have indicated both the location of the transboundary aquifers as well as the transfrontier conservation areas as we know them today in the SADC region. And with particular focus on the CASA TFCA, it spans 520 square kilometers. That's about 2.7 million people. And we deal with 5 countries: Angola, Botswana, Namibia, Zambia, and Zimbabwe. We also cover, or the park or the area covers 2 river basins, so both Okacom and the Okavango Basin and the Zambezi, and the associated river basin organizations, which are the Okacom and the Samcom. Geologically, we're talking about a setting which is mainly, not all, but the part that we're looking at presently is part of the Kalahari-Karoo Basin. And as you can also see within the green area there's at least 5 TBAs, or transboundary aquifers, within or sort of shared with the TFCA, including the Eastern Kalahari-Karoo TBA that was mentioned today. And I haven't revised the boundaries as Hans Beckman was telling today. You have to excuse that. But just to say that there's other work going on in the area. In terms of the other 4 TBAs in the area, relatively little is known. And you can see there's one there in the very middle, which is shared between 4 of the countries or even more. So that is a very interesting one to get our heads around as we go forward. Just a little bit of the background. So Transfrontier Conservation Area, of course, deals with conservation. And so the framing of the CASA TFCA is not in terms of water resources, but rather in terms of conservation and the natural, integrity and the beauty of that area. And of course, also the economic interests associated with tourism and so on. This area has the largest contiguous population of elephants in the world, and of course, a lot of other biodiversity and unique ecosystems. Imperatives, climate variability, climate change. We've seen decreasing rainfall over the last years and larger variability, as has been seen in many areas across the region. Population growth, about 2 to 7% per year. A lot of economic growth as well, even within the area. It's not all protected. It's a mix. It's a mosaic of protected area and non-protected area, but they try to make corridors between them. So all the sort of the biodiversity infrastructure, if you like, is inert or intact. And that's sort of the beauty of the CASA TFCA. But in between, we have economic growth in terms of infrastructure and mining and commercial agriculture. And all of these things are, of course, stressing the system on top of the climate change and so on. And then, of course, the conservation is a larger imperative as well, as I just mentioned. And I write here groundwater imperatives because it's important to understand that now the interest is on groundwater in this area. And the impetus for taking on the study was some of the points that were raised at a meeting in 2019, where groundwater was put forward as a resource we don't know very much about, that is the weakest part of the climate studies. We don't know what happens to groundwater with climate change. And there's a lot of opportunities, on the other hand, in terms of developing groundwater for water security and resilience and so on. So that's sort of the background to this project. Now, because this is such a huge area, we decided to narrow in on a smaller area. So the study area is here seen as the upper western corner of the Casa TFCA, which includes the Quando River Basin and what they call the Quando River Wildlife Dispersal Area in yellow here. And so the intersection between those two is our study area. The Quando River Basin is part of the upper Zambezi River Basin, as you can see to the right here. And it's running sort of in parallel with the tributaries to the Okavango River. And there's a lot of similarities between them. And the Quando Basin is also partially endorheic, sometimes not. It connects to the Zambezi River further downstream. It's, of course, the headwaters, and it's in Angola. And so whatever happens up there is quite influential on downstream water flows and so on. The river is very important for, the groundwater is very important for base flows. The river is very stable. It doesn't change as the other rivers, which tells us the interaction between surface water and groundwater is quite unique in the system, and it's very much groundwater fed, even though we don't know the specifics and the details as of yet because the research hasn't been done yet. In terms of aquifers, the upper part you can see there in the photo, very flat. And then if you go further down, you will see a lot of sort of, what do you call it, interruption of the geology due to various geological structures, faults and dikes and so on. That means that the system is very complex. And this is actually where the transboundary setting is. So understanding the transboundary aquifer here is going to be quite complex. This work that's shown here is credit to BGR, who's done some very detailed work so far, but we haven't quite gotten our head around the transboundary context and also the link back to the upper part of the river basin that is actually feeding this lower part of the basin. Of course, when we're talking about groundwater, so it serves multiple purposes already, drinking water and domestic water, also smallholder livestock productive uses, and of course, ecosystem services, as I already mentioned, which feed the rivers and then feed the wildlife. And with the climate change and stress on water resources, we also see stress on wildlife. We also see wildlife and human conflicts. And one of the aspects we're also looking into now is to see if there's further scope, and it's actually being looked into in some of the parks, whether it's necessary to drill for groundwater to be able to feed the wildlife during stressful times, as you can see indicated here. In terms of what we've been doing in the project, so we've been looking at a transboundary diagnostic analysis, and it's now in a consultative process through engagement with the existing structures that are already in place between the various countries that we're talking about here. So we have the 4 countries, Angola, Botswana, Namibia, Zambia, and Zimbabwe is not part of this part because it's the upper part of the basin. But we're bringing these partners together to get feedback on what we have done in terms of a desktop analysis of existing information, focus on groundwater and aquifers, but also interdisciplinary in terms of socioeconomics and so forth, and also looking at the institutional and legal aspects. We are looking at the ecosystem services that are dependent on groundwater. This is work we're starting up with the World Wildlife Foundation, who's already a Worldwide Fund for Nature, that are already heavily engaged in the area. Then we have done some vulnerability mapping and combined that with groundwater potential mapping. So looking at where it would make sense to actually develop groundwater further for vulnerable communities and vulnerable wildlife in the particular area. And then finally, the last part of our work is to look at a transfrontier conservation management framework. And the idea of that is to look at those aspects that are of particular interest to transfrontier conservation area and the conservation aspects. How do we bring that in when we're dealing with groundwater? It might be a bit underrepresented in the SADC, in the present SADC frameworks for groundwater, and also in maybe even at the international level in terms of legal frameworks and so on. So that's something that we're looking into now to fill that potential gap, if you like. And then in the future, we hope to be contributing towards a strategic action plan, first of all, for the Kondo River, and in collaboration with the partners. And then sort of the overarching aspects of TBA governance in this context. I mentioned already the Natakaru TBA, and you can see here how it's been already mapped. It's not very well delineated as of now. There's a lot of uncertainty, and there's a lot of work that needs to further go into this. We are not able to do it in this project, but we are getting feedback in terms of interest in taking this work forward because of the interest in the water resources and the groundwater here. We have the OCACOM and SAMCOM and CASA coming very close together in a triangle, if you like, to all address the water issues in this huge area, which also encompasses Okavango Delta, if you like. And so there's a very good scope for working across the river basins as well as these TFCAs. And if you noticed in my previous slide, I think maybe you can look here and you can see there's a lot of overlap between the TFCAs and the transboundary aquifers in SADC. And so it's very important that we get our head around this, and the CASA TFCA is sort of leading in that sense. Now we're also collaborating with the Ramsar Convention, because they are also now getting more and more aware of the aspects of groundwater. And so understanding how we can enhance those aspects in terms of conservation for the benefit of not only conservation, but also in terms of livelihoods and the larger good. And all of this is creating a lot of cross learning and cross-boundary synergy, as long as we are all, I think, communicating and doing these things in conjunction and using sort of the same engagement pathways and so on. So that's a very critical part of the project. And then my conclusions. So there's a need for greater focus on the role of groundwater in local water security, livelihoods, wildlife, and environmental flows in TFCA and conservation frameworks in SADC and maybe even broader. There's also need to look at greater integration between the TFCA and the TBA frameworks, as I mentioned, that this is something that we're trying to look at. And then in strengthening the river basin organization cooperation around these, what we call trans-basin aquifers, so like this Natakaru that I mentioned, because normally the TBAs fall within a single river basin, but there are cases where they don't. And so that's another thing we need to further collaborate on. And there might be many countries and basins involved, but nevertheless, it's something we need to get our head around as this gets more and more important. And then I think both the groundwater and the TBA work is going hand in hand in the regional bodies that are now established. And so this is very a good way forward. I think we've seen that in other presentations in the conference, and I think we'll see it further in other presentations later in the session. So I think we all agree on that. And then I think just to end up by saying that the next phase will be to look to get further understanding of the groundwater in Angola primarily, and also around the TBAs in the upper parts of the CASA TFCA. So I'll end by that, and thank you for your attention. Thanks, Chair.
Thank you, Karen. It was a very interesting presentation that puts on the table the interaction between transboundary water resources with transfrontier conservation areas, and how their assessment and management can be carried out in a broader context of governance for such an important region. There are many issues involved, and it is not easy deal with them in a coordinated form. Obviously, thank you again. Well, I just want to remind that attendees can address questions to the panelists in the Q&A box. Please, you can put your questions there. Continuing with the next presentation, it now corresponds to Arnaud Sterckx, who works as a researcher at the International Groundwater Resources Assessment Center, IGRAC, which is a center under the auspices of UNESCO. Mr. Sterckx's presentation is entitled Advancing Transboundary Cooperation in the Senegalo-Mauritanian Aquifer Basin. Arnaud, the floor is yours.
Thank you, Alberto. Can you see my PowerPoint presentation on the screen?
Yes.
Yes? Okay.
Yes. Not yet.
Thank you very much. And thank you for introducing me. I will indeed present the recent advances in transboundary cooperation in the Senegalo-Mauritanian Aquifer Basin. And first and foremost, I want to acknowledge the leading role of the countries who created this cooperation from the start. So the Gambia, Guinea-Bissau, Mauritania, and Senegal, with the support of the two river basin organizations, OMVG and OMVS, so the Gambia River Basin Organization and the Senegal River Basin Organization. And in particular, I want to thank the focal persons who have been sitting in the regional working group. So Youssoufa and Landing Boyang from the Gambia, Hilario Sanya and Crisostomo Alvarenga from Guinea-Bissau, Saadou Ebimonan from Mauritania, Nyoko Ndour and Professor Serine Faye from Senegal, Lamine Konate from OMVG, and Lamine Ndiaye from OMVS. And I don't think any of them will be with us today because unfortunately we were supposed to have a meeting of this regional working group today. So, but if any of them is here, please feel free to pop in at the end of this presentation on later on during the question and answers. I also want to thank my co-authors, Francesca, Alexia, Mustafa, Anuka, François, Comlan, Raya, and Jean, who've also been supporting this process as part of the facilitation team, composed of the Geneva Water Hub, the Secretariat of the Convention on the Protection and Use of Transboundary Water Courses in International Lakes at UNEC, and IGRAC, International Groundwater Resource Assessment Center. So the Senegalo-Mauritanian Aquifer Basin is a large sedimentary basin stretching along the Atlantic coast in Western Africa. It covers a part of Guinea-Bissau, all of the Gambia, a significant part of Senegal, and also a part of Mauritania. And the population in the basin was estimated to about 16 million a few years ago. And all four countries depend mostly on groundwater resources. As you can see, whether it's for urban or for rural water supply. And as you can see on the figure, the basin intersects two river basins, the basin of the Senegal River and the basin of the Gambia River. So this groundwater is shared by four countries and two river basin organizations, and there are also groundwater challenges and issues in common, such as the demographic growth, which is expected to increase the stress on water resources, as well as the social and economic growth in the countries, climate change, of course. There are water quality issues, whether natural or anthropogenic. The legal and institutional frameworks are generally weak in all four countries. There are ongoing reforms which have not been finished, or when they're finished, the regulations don't follow. And there is a gap in information. There is not enough information about those groundwater resources, about the the extent of the different aquifers and aquithards, the recharge rates and the recharge areas, the vulnerability of the resources. And for instance, we don't know how much groundwater flows across the borders. So really, it's a lack of information which relates to some gaps in data collection, interpretation, and dissemination of information in the countries, which themselves relate to a lack of funding of the institutions in charge. So because this groundwater is in common, and because those issues are also shared by the countries, the 4 countries engage in a regional cooperation process. There was already in February 2019 a roundtable held in Geneva with the representatives from the 4 countries, from the river basin organizations, and several other organizations. And then this cooperation mechanism was formalized in October 2019 by the 4 ministers of water, who created a regional working group. And this regional working group, so including those representatives from the countries and from the river basin organizations, was given the mandate to create a permanent mechanism of cooperation on groundwater resources in the Senegal-Mauritanian aquifer basin. So during the summer 2020, several deliverables were made, and I will come back to that in the next slide, to make a diagnostic of the situation. And then based on those deliverables, a joint vision was made, and an action plan, a project for 5 years, including a series of action. So there were several meetings, of course, with the regional working groups, some on-site, some online, of course, because of the pandemics. And eventually, after several months of work, this joint vision, there was an agreement on this joint vision and on this joint project. So the deliverables I mentioned, including several diagnostics of the situation, one on the state of groundwater resources in the basin. There was a report, a diagnostic of the existing data on groundwater in 4 countries, a diagnostic of the capacity in terms of groundwater management, data collection, interpretation, etc., in the 4 countries and in the river basin organization. And for this deliverable, several interviews were organized with tens of groundwater professionals. There was also a review of the legal and institutional frameworks, and also an overview of models of transboundary cooperation elsewhere in Africa and in the rest of the world. And like I said, based on this, on those deliverables, then a joint vision and a joint project could be developed. And I forgot to mention that we also set up an information management system containing the information we could collect during those this diagnostic. So the joint project, here is the logical framework. The main objective is to promote the resilience and the sustainable development and stability in the region through the strategic, integrated, and collaborative management of groundwater resources. And there are 3 components to this project. One is improving the integrated and sustainable management of groundwater resources. This is mostly a component of knowledge acquisition, including the strengthening of data collection, monitoring networks, and etc. Second component is to strengthen the governance for cooperation, protection, and equitable and efficient use of the resources. So that includes the strengthening of the governance framework in the 4 countries, but also at the regional level with a permanent mechanism of cooperation. And the first component is to strengthen the political commitment and develop sustainable financing mechanisms. I'm not entering into details and describing all those the resource, and then all the resources is divided into several activities. So there is no time for that. But the budget of this project was estimated to more than $8 million. And well, the good news is that we already have an opportunity of funding from the GEF via UNEP. This is a first opportunity. Apart from that, contacts have been made with other potential donors because this project GEF would not be enough to cover the entire project. And then apart from funding from external donors, it's also important that the states contribute to those activities because we want to avoid that at the end of the project, all the outcomes get lost because there is no continuity in those activities. So we need to see if the countries can contribute, whether with the budget from the states, or if they can set up some alternative or additional mechanisms to raise funds to finance the cooperation on groundwater resources. But yeah, this will take time to find out the right mechanism, but also to agree between the countries on the share, how much each country would contribute. So that's actually an important component of the projects to find out about those financial mechanisms to support the sector and the strategies to develop that. So recently in September, there was a meeting in Geneva of the 4 ministers of water, where they validated the work of the regional working group so far, and they signed a declaration in which they strengthens the regional working group and further define its mandate, which is to promote, to operationalize the exchange of data on groundwater resources in the basin. That's the first mandate. The second is to develop a permanent mechanism of cooperation. And the third mandate is to raise funds to finance those activities and coordinate all projects in the region related to groundwater resources. And the fourth mandate is whatever other task that would be agreed between the 4 countries. So the new, its new version, the regional working group will be composed of 2 members of each member state, 1 representative from OMVG, 1 representative from OMVS, and also 1 representative from OSS who join the regional working group. And the secretariat of the regional working group will be assured by OMVG and OMVS jointly. That will be a joint effort between the 2 river basin organizations. And the regional working group will continue receiving the support of the 3 facilitating agencies. And this is the last slide to emphasize the instrumental role of the 2 river basin organizations in this regional cooperation process. Because of course they know everything about the water challenges in the region. They have extensive, they have experience in transboundary cooperation among the 4 with the 4 member states. They have experience in data sharing, data exchange in the basin, and also in managing international projects. And there is a growing interest at OMVG and at OMVS to gradually integrate groundwater, according to integrate water resources management principles. And for instance, OMVG has launched or is to launch a new platform, information management system, including data on groundwater. At OMVS, they also engage in a sort of diagnostic of groundwater monitoring in the member states, and also starting an assessment of groundwater resources in the basin. So there is this interest of the two river basin organizations to address groundwater assessment and management. So the support is very much welcome, because the regional working group for now has no status to receive fundings, to manage fundings, to hire staff, and etc., to manage projects. So this role will be taken over by OMVG and OMVS. And the fact that two other countries are part of OMVG and OMVS, Guinea and Mali, are not part of the Senegal and Mauritanian Aquifer Basin, has not been seen as an issue. On the contrary, and two countries have been invited in the ministerial declaration to follow the work of the regional working group as observers. So I'm stopping here. I think I'm right on time, and I thank you for listening.
Okay, thank you, Arnaud. Good presentation, and I would like to highlight as a relevant aspect that this is to exploit groundwater resources in a more efficient and sustainable way, in support to regional development by improving the knowledge and the governance. And I want to highlight the process involved that involved a strong dialogue, political dialogue between countries, and three important issues: cooperation, financing mechanisms, in order to achieve a better management. It's very good. Thank you. Well, for the next intervention, I will present Francesco Sindico. Francesco is a co-director of the Center for Environmental Law and Governance at the University of Strathclyde in Scotland. And his presentation title is TBA Agreements and Arrangements from Paper Tigers to Effective Implementation. Francesco, a pleasure. The floor is yours.
Buenos dias, Alberto. Hello, Alberto, and a huge hello to everybody in the conference. A huge thanks to UNESCO IHP for organizing together with all the other partners. So I will give you a break from slides. I will not have any slides. I will just give you a presentation. So my presentation actually works very well, I think, after the one we just heard from our esteemed colleague. There are some parts of it that I will relate to it. And it also works well after the extremely interesting session on draft articles on the law of transboundary aquifers that took place just before this session. The presentation will be in three parts. The first part will give a little bit of a context on the research and what I'm going to say in my presentation. The second one, I will try to answer whether transboundary aquifer agreements and arrangements are just paper tigers or not. I will explain what I mean by paper tigers. And the third part, I will highlight a clear pattern, at least in my opinion, related to donor-driven projects, transboundary aquifer agreements and arrangements, and the implications that these projects have on seeing them or not as paper tigers. So let's start with the context. As you can see behind me, I finished a book last year called International Law and Transboundary Aquifers. And the remarks I'm going to make today relate very much to chapter 6 of this book. And in that chapter, I do three things. The first thing, I highlight the difference in legal terms between an agreement and an arrangement when it comes to transboundary aquifers. I will not expand on that, but I can say that at least in my own analysis, we are now having 7 agreements and 5 arrangements. I haven't had the chance to really dig into the Senegalese Mauritania document, let's call it like that for the time being. So I'm looking forward to do that as well. The second part of this chapter looks at the normative content of agreements and arrangements. And the third part is really where I want to focus today. And it's about, I call it the implementation landscape and emerging pattern. But the second part of this presentation is really about whether these are paper tigers, these agreements or arrangements, or whether they have a life of their own. So let's start with a life of their own, whether they're effective. To say that an agreement or an arrangement that has been signed and that 2 or more countries are, at least in principle, using to manage their transboundary aquifer, that to me means that there has to be an institutional and normative follow-up after their adoption. If you don't have that, then you have a paper tiger. You have just a beautiful paper, but it's actually just not something that really works, let's say. So another way of seeing it is if you have an agreement, for example, the Guarani Aquifer Agreement until recently was not in force, you could have called it a paper tiger. We all talk about it, but it doesn't really do anything. Now, another way of seeing a paper tiger is you have the most beautiful written agreement or arrangement. Everybody quotes it, everybody refers to it, but actually there are 2 key problems. One, there's lack of funding. There's no money involved. There's no budget. You would want it, but it's not there. And the institutions that have been developed cannot work because of lack of capacity. Again, if you are in that situation, you have a paper tiger. So funding is necessary for so many things, but for example, to monitor and collecting data. Most of these agreements or arrangements refer to this need for funding for monitoring and data, because the agreements and arrangements related to the Eulamidan, the Nubian, the Northwestern Sahara Aquifer, the Ocotopeque, the El Paso Juarez, the Stampede, and others. What about the institutions? When can we say that an agreement or an arrangement has an institution that actually makes that specific instrument work and not just be a paper tiger? So in my opinion, there are 4 key aspects. The first one is you have to ask yourself, has it even been created? It's all great that it's on paper, but if it has not been created, how is it going to even work, obviously? The second, once it has been created, is it carrying out the activities that it has been tasked to? Again, there may be problems of budget or capacity there. Is it meeting regular? Okay, you have an institution, but it doesn't meet regular. It meets once every 4 years. Is that really an effective agreement, or is it just a paper tiger? Are its meetings records available? Is there transparency? And this, I think, is an issue for some, at least from the public. It's not very easy to find these minutes or find this information. Now, the one agreement/arrangement that I do think has all these 4 criteria is the Genovese Aquifer. There, you do have all of these 4, and there is some agreement amongst those who work on transboundary aquifer policy and management that the Genovese Aquifer, in this sense, is an example of good practice. But even in my work and my research work, I have tried to find these criteria in all the other 12 agreements, arrangements, and my conclusion is that it's really unclear. It's really unclear the extent to which these institutions exist, whether they're happening regularly, whether they have the capacity, whether they have the funding. So the picture is not really too positive in that sense. I'm sure there are aspects that I have not seen or have not found, but overall, I do not think that most of these agreements have that strong institutional funding capacity that they should have. Now, let me come to the third and final part of my remarks. And this is about a clear pattern that I believe has taken place over the past 10, 15 years, at least, in transboundary aquifer management. And it's that agreements and arrangements, call them as you wish, that we can see around transboundary aquifers, are mostly a result of donor-driven projects. And I don't say this in a positive or negative way. I think it's quite objective that they are the result of these donor-driven projects. So let's think about these donor-driven. What are their primary goals? And this was very clear in the Guarani region. There are three key primary goals. The first is to increase scientific understanding of the transboundary aquifer. This was clear also from what I understood of the Mauritania-Senegalese, for example, project. The second is to assess the socioeconomic and environmental importance of the transboundary aquifer. And the third is to map groundwater domestic law and policy. Now, what is interesting to see, and those like Alberto who have worked on this on a daily basis, will have seen that through these projects, through these three goals, what actually happens is that you build trust between the countries. And even more importantly, it fosters a network of experts between transboundary aquifer countries. And this is all great. This is the glass half full. You have these projects and they build the momentum. The problem with this trend is that what happens when the project finishes? Because if the project finishes, the agreement or the arrangement that we have all celebrated back in 2010 when the Guarani Aquifer Agreement was signed could convert itself in a paper tiger if countries do not follow on two things, funding and institutions. So instead of just complaining about, let's think, how can countries who have signed an agreement or an arrangement, who do not have any more funding, how can they transform the paper tiger into something more effective? So obviously one answer could be, well, just go find more fund, just find more money, another donor-driven project. Now, I'm not saying that's not a good idea, but it does create a never-ending cycle, which I do wonder how useful it is in the long term. So then another option is, and I'm not saying it's easy, I'm not saying you just do it like that, is to boost domestic capacity and raise groundwater/transboundary aquifer relevance within domestic policy circles. So what I'm trying to say here is that if for whatever reason the donor money stops coming, the countries need to take responsibility. And I know some countries will be LDCs and they have little budget and so forth, but at the end of the day, all countries do have a budget, even if it's very small. So they need to take responsibility as well, at least in my opinion. Again, rather than just stopping to that, let's think of how they can do it. Now, one way of doing it is, and this is, I'm the first one to realize that this is in a way just words, but to identify local champions that can link groundwater and transboundary aquifer to policy environments within that country that resonate more also from a budget perspective. And those, in my opinion, could be, for example, climate change and the SDGs. Who are these local champions? Now, again, that we would need to go to the specific country, the specific context. This is a lot about education, obviously. The local champions just don't happen to arrive from one day to the other. There needs to be hydrogeological groundwater management interest in the universities and schools and so forth. But the second thing, and here we could go back to donor-driven projects. But once you have an agreement, once you have an arrangement, surely you still need to boost the scientific understanding because aquifers are complicated and so forth and so forth. But if you have one of those 12 agreements/arrangements, then projects can be framed in a way to boost capacity building directly related to implementation of the agreement or/arrangement provisions. So that's where I stop. And Alberto, I thank you very much for giving me the floor.
Thank you, Francesco. Great presentation. I think the difficulty in signing transboundary groundwater agreements or documents around the world is very clear. We have only a few, but it appears even more complicated to make these agreements fully operational. We have a lot of examples. Much remains to be done in terms of cross-border cooperation so that the implementations of the agreement became a reality. Very good, thank you. Well, our next speaker is Pete Kinabato, Professor Kinobato is hydrologist and water resources scientist at the University of Botswana. His presentation is making a case for groundwater governance in Southern Africa and the role of RBOs in implementation of groundwater governance regimes, the case of the Stampede transboundary aquifer system in the Orange-Senku River Basin. Professor, the floor is yours.
All right, thank you, Chairman. Let me check if you are able to hear me.
Yes, we hear you and we see the presentation. Thank you.
Thank you. Thank you, Chair, and I want to thank you for this time that you've given me, and you've introduced the topic, and I want to start by acknowledging the contributors in one or the other, particularly UNESCO, Orascom, and the SDC, the three governments of Botswana, Namibia, South Africa, and also my colleagues in terms of the focal points for the Stampede particularly. So that's the presentation. Okay. Sorry, I'm struggling with my video. I think it has a problem. But I suggest that I move on without my video, if it comes maybe later. Can I go ahead, Chair? All right. Okay, yeah, so I think, sorry about that. Yeah, in terms of the background, Chair, I want to suggest that groundwater is very key in many of our African countries. And statistics show that about 75% of our African population relies on groundwater, especially in our rural communities. But despite its strategic role in people's livelihood, the management and the understanding of groundwater is very poor. And over the years, it is noted that transboundary water resource assessment and management have mainly focused on surface water and river basins and less on groundwater. So I think those also have been made earlier, so I thought I should just mention them. And then in terms of the mapping and the issues around groundwater, for example, you only have about just a small number of aquifers that have been mapped, and most of them really are not necessarily in Southern Africa, but elsewhere. So about 72 TBAs, they underlie about 42% of the African continent have been mapped. And only out of these, only 11 or 15% have been subjected to detailed scientific studies. And interestingly, 34 of these are in Southern Africa. That is those that have been mapped. And then although some of these have been researched in much detail, I think it is very key that scientific information and knowledge on these characteristics of the aquifers themselves and the processes underlying them is lacking or difficult to obtain, mainly due to data issues and capacity and many others. So in a way, cooperation relating to groundwater governance has been formalized. I think now this number keeps increasing, but I think for now, let's just say it's less than 10. But out of this, really, you can see that most of them are not in Southern Africa, but largely in North Africa and the Sahel, as you have heard from some of the presentations. So in terms of this in Southern Africa, there is an urgent need to do in-depth assessment of these TBAs and also establish groundwater governance in one or the other in these TBAs within Southern Africa. So I'm just going to present a landscape, what I will say, reflections on recent developments that are actually making us to realize that there is a prima facie case to move towards governance of groundwater. So between 2013 and 2021, I think you have had some of these aquifers and transboundary aquifers that I'm presenting here. For example, the Stamford transboundary aquifers, and all the way from 2013 to present. And I think that means a lot in terms of some of the things, activities that are currently ongoing in terms of facilitating formation of groundwater governance. And I have also highlighted the countries involved, Botswana, Namibia, and South Africa, and then the institutions that have played a key role in those in implementation of these projects, UNESCO, IGREC, and the SDC, and also highlighted the river basin organizations, which are the subject of this discussion. But in each of these transboundary aquifers, I've tried to present the key achievement as well. For example, for the Stamford, the TDA has been completed, and as well as the groundwater model in terms of the integrated hydrological model, and on the strategic action plan as well. And then the MCCM, which is the multi-country cooperation mechanism. I think that's one of those that Francesco referred to earlier on in terms of these arrangements or agreements. And then others that are coming on board, thanks to Karen, I think she presented the Ramudza, which as you can also see, IMWI was quite involved, and then IGREC, as well as the funding agency, which is USAID, and then LIMCOM. In terms of the countries involved, Botswana, South Africa, and then some of the key achievements, the TDA, and also development of the groundwater model, which to some extent, well, can still be improved, but at least it has been developed and is quite working. And then the strategic action plan as well. Other TBAs, the Shira one that Karen also presented, but in terms of the institutions, now you see another institution coming on board, which is the SADC Groundwater Management Institute. I think is very key there. Also, in addition, the IMWI again. And then in terms of the RBO, we moved from Orascom into LIMCOM, and now we are in ZAMCOM. And also for this Shira, in terms of the other key aspects, the TDA has been completed, and as well as the strategic action plan. And all these activities and achievements, really, they are pointing towards a unique landscape where we can tap from this and move our TBAs to another or to the next stage. And then the Tule Karoo, Botswana, South Africa, and Zimbabwe. The institutions, again, you still have the SADC, GMI, IMWI, thanks also, and also the funding agencies, the USAID, LIMCOM also coming on board as a RBO. And then in terms of some of the key achievements is the TDA. The strategic action plan could still be already be there, but at the time of compiling the information, I didn't have access to that. But also another one quite recently is the Eastern Kalahari transboundary aquifer, where you've got, again, SADC GMI, and then other institutions such as the L2K2, which is one of the upcoming or leading hydrogeological key player in the SADC region. And then the key river basin organizations, the ZAMCOM and the OGACOM, in which this TBA lies. And in terms of the achievement is the TDA and the strategic action plan. And over and above those, there are some institutions that in a way, in one or the other, they played a key role. And I want to refer to the next session, I think it's session 13, where you will hear more about the groundwater model for the stars from one of our colleagues from the Avignon University in France, Prof. Marc LeBlanc. And I just want to submit that based on this landscape, an opportunity exists really to move towards formalized groundwater governance for improved groundwater management in our TBAs. And I think in a way, one or the other, it will support what has just been said by Francesco, especially in terms of making sure that the implementation is done. With this, really, I want to also move quickly and just look at the stars. These are the maps, colleagues, that you can look at there. But on the right also there, you've got the distribution of the Karoo in terms of the region in Southern Africa. And you can see that it characterizes most of the TBAs that I even talked about. In particular for the star, so you can also see the cross sections there, which actually looks into the major aquifers, including the top ones, which is the Kalahari, which really runs through the cross sections, both from the Namibia side into Botswana and then ultimately to South Africa. And then there is some groundwater integrated hydrological model, which is very key, because in this, it integrates both the unsaturated and the saturated zone, which I think is quite key, as well as integrating the climate, as you can see at the top there. This is also some additional information regarding the stars. Is quite huge in terms of the recent information. And then also the population is quite small, by the way. In terms of the hydrogeological units, mainly the Karoo Formation, and on top is the Kalahari and the two lower aquifers interspersed by the aquiclude in between. And then the rainfall is quite small, 150, 250, while the evapotranspiration is really huge, especially the potential evapotranspiration. The land use is quite mixed, and you've got irrigation, the tourism, and also the Trans-Kalahari Frontier Park and the wildlife management area, particularly in Botswana, for the wildlife management area. And then for the groundwater governance, this is the multi-country cooperation mechanism that I referred to earlier on in terms of the ORASCOM. Now, I think just to move towards narrating how it all started, if you look at this really, you can see that in 2017, the STARS multi-country cooperation mechanism was established as a permanent institutionalized cooperation among the three countries, or at least moving towards that if all things hold together. So this is also nested within the ORASCOM structure, a river basin organization. So this cooperation arrangement is expected to generate flow of information, data, in terms of contributing to some of the strategic objectives of ORASCOM. And even more importantly, we think it will also assist to move from just the project data collection, scientific studies, towards more important thing of exchanging information and joint strategizing or management of the TBA within the STARS countries. And also now, even more importantly, we think that even coming up with the strategic action plan in 2020, as well as the good work that has actually been done in terms of developing the numerical integrated hydrological model, we think these are deemed key for forward planning and implementation of this. Of course, there are other key issues, but I think this can go a long way in terms of demonstrating how to move beyond just the project. So in terms of those who want to see how it is instituted, this will be within the ORASCOM under the task teams. It will be under the task team that is responsible for technical work, in this case, underwater resources quality working group. Then we've got the groundwater hydrology committee, which actually is very important in terms of what it has been doing. The three countries felt that it could be facilitated through the groundwater hydrology committee. And then under the representation from the countries, there will be some focal points. And as I speak, those are now being constituted in terms of now moving towards multi or transdisciplinary, the hydrogeology represented, the legal and institutional aspect, as well as the gender. So those will really be part of those that represent the countries in terms of implementing the mechanism. And of course, we've got other key players, such as the SADC GMI, who will come as an invited, as an ex-officio, and supported, of course, by the three governments. Hopefully, if it moves forward, then some of the funds should actually come from the countries in a manner that they have been supporting ORASCOM. from
Professor,
the beginning.
you have 1 minute.
Yeah, so I move towards my conclusions, Chair, in terms of the key lessons, is that RBOs can play a key role to promote groundwater-based climate adaptation. So many RBOs already have climate adaptation plans. However, many of these are actually mainly on surface water. And RBOs are increasingly considering the importance of groundwater in their mandate and activities. So these activities really can greatly contribute to climate adaptation plans, especially moving towards implementing key things such as managed aquifer recharge in some of these TBAs. Institutionalizing cooperation is key for sound groundwater governance at regional level. And also assessment of the TBAs has led to generation of new insights, which I've already demonstrated. For example, revised aquifer extent, aquifer properties and dynamics, which actually has now surfaced as new information. So groundwater assessment is not only about science, but also how it can be used to improve or develop policy and legal frameworks. So understanding how the aquifer works and also developing some tools to help with the management. I think that is key. This is my last slide, Chair. And I think I'm proposing that in terms of moving forward and for continuity, there's need to train future scientists, particularly through capacity building. So building synergies with university is really key here on topics such as groundwater governance, groundwater modeling, and so on and so forth. But I also want to mention that there is no one-size-fits-all solution for institutionalizing this cooperation over transboundary aquifers. But you can learn from some recent case studies, including one that I just presented. The last point, Chair, is that we can actually make use of and empower existing regional and local institutions to improve groundwater management in the region. Here, for example, the SADC GMI is quite key and really needs to be supported in the work that it is doing, looking at the recent work where it has been involved in the TBAs. And with those, Chair, I want to thank you and thank you for your attention.
Thank you, Git. Good presentation. And I want to highlight the importance of looking for a mechanism for the institutionalization of cooperation for the management and governance of the transboundary aquifer, since, as Francesco said previously, and also you, since there are many examples in the world of how these aspects do not have continuity once the project is finished. Thank you. We are now, we have 4 pre-recorded presentations, and we'll start with Brighton Munier, who is Senior Groundwater Specialist at Southern Africa Development Community Groundwater Management Institute. Please, the technical team will share the video from Brighton Munier.
Greetings. My name is Brighton Munyai from the SADC GMI. I'm going to talk about rolling out institutional arrangements for transboundary governance in the SADC region. The SADC region is home to about 30 TBAs, with some work having been conducted in 5 TBAs. And transboundary waters and transboundary aquifer governance is guided by the SADC Protocol on Shared Water Courses, which is also important in the setup and operationalization of river basin organizations, which provide an important intermediate institutional structures for the management or governance of the transboundary aquifers. Some work has been done in terms of setting up governance institutions for transboundary aquifers in the SADC region, notably work in the STARS and in the Ramotswa transboundary aquifer. The STARS transboundary aquifer, found in the Orange Sengu River Basin, was the first in the region to formalize arrangements for its governance in November 2017 through nesting in the Orange Sengu structures, and with the long-term vision of joint strategizing and advising STARS countries on the management of the aquifer and its resources. 2018, a project advisory committee was established in the Ramotswa transboundary aquifer of the Limpopo River Basin, and its prime role was to provide advice to the project management team that was implementing the Ramotswa Transboundary Aquifer project. On the right, what you have is a diagram of the STARS Multi-Country Cooperation Mechanism, abbreviated MCCM, and at the bottom is the MCCM model as it evolved from a project that was being implemented in the STARS Transboundary Aquifer system. And the point of nesting into the ORASCOM structures is through the Groundwater Hydrology Committee of ORASECOM. And noting is that the ORASECOM structure also includes Lesotho, which is not part of the STARS multi-country cooperation mechanism. And this has got an important bearing when one starts thinking of ways of rolling out the STARS MCCM. So in attempting to roll out the STARS model, which is considered a success, which we also consider a success as the SADC GMI, we are faced with two critical questions that have to be answered as one is trying to roll out the model. The first one being, does the STARS MCCM model cater for all the TBA scenarios in the region? And by TBA scenarios in the region, we are talking to scenarios 1 to 4, which I will not go through because of time. And the second question is, how do we adjust the MCCM model to cater for these scenarios, those 1 to 4 on the left? And what is probably noted at this point is that the STARS MCCM model provides a starting point which can be altered depending on the unique features of the TBA and TBA or the RBO and the member states in question. It is not a one-size-fits-all model, but it provides a very good basis to conceptualize and set up institutional arrangements for the governance of transboundary aquifers, taking advantage of the existing river basin organizations which have embraced transboundary aquifer management, transboundary aquifer governance as one of their key mandates. With that, I thank you for your attention. I've come to the end of my presentation.
Okay, thank you very much for presenting us the progress of this project that will collaborate in improving governance in that region. Next presentation is made by Imad Antoine Ibrahim, who is Assistant Research Professor, Center for Law and Development at College of Law, Qatar University. Please, can you share? Okay.
Good morning. In this presentation, I will examine the governance of the Red Huma aquifer that is shared between several countries in the Gulf area here in the Middle East, in the MENA region, sorry. So let's start from the beginning. The Red Huma aquifer is shared between Qatar, Iraq, Kuwait, Oman, Saudi Arabia, and United Arab Emirates. In Qatar, it has begun to be used in the 50s. This aquifer is being heavily exploited for various reasons, mainly agricultural purposes, domestic and industrial purposes, by all the nations sharing it. So far, there is no water agreement regulating its exploitation and long-term preservation and protection. Therefore, cooperation between the countries is important. Such cooperation can be noticed only within the Gulf Cooperation Council in the form of investments in water infrastructure projects. Cooperation and joint management between countries is needed to ensure the long-term sustainability of the aquifer and to prevent the existing risks from completely depleting it through the adoption of joint policies for groundwater resources management. So, how can cooperation take place? First, the main problem of the aquifer is there is bad management practices in the transboundary context. that is affected by the absence of an actual concrete cooperation in this regard between all the nations sharing the groundwater. This absence can be noticed at all levels. Unfortunately, in this context, international legal conventions and rules have not been considered so far in the management of the aquifer. Although these rules play an important role, mainly the draft articles on the law of transboundary aquifers and the Water Courses Convention of 1997. Therefore, there is a need to address the governance of this transboundary aquifer in order to strengthen cooperation between the countries sharing it. There is also a need to figure out the ways through which the various states sharing the aquifer can be incentivized to cooperate for the establishment of transboundary water agreement. Hence, international law should play a very important role in this regard via the establishment of basin water agreements. Thank you very much.
Well, we see here the importance of establishing cooperation mechanisms to face a situation of an aquifer system threatened by its intensive exploitation. Thank you very much. We are going to our third presentation by Maureen Walshot, who is PhD candidate, Université Catholique de Louvain and University of Haifa. Please, you can share the video. Thank you.
Dear all, my name is Maureen Walshot. I'm a PhD candidate and teaching assistant at UC Louvain in Belgium. I'm glad to be presenting a piece of research I've been undertaking on water security, gender, and transboundary aquifer management in Central America. While Central America is endowed with water resources, water scarcity remains a concern in the region, given the lack of mechanisms and actions for national and transboundary water management. Moreover, vulnerability to climate change is a critical issue. The intergovernmental instruments signed so far have proved insufficient to establish and implement agreements for managing and integrating development of international watersheds. Besides the lack of regional cooperation, the issue of gender in the context of water security in Central America can manifest itself through various modalities and dynamics. As the active participation of women in water diplomacy is critical to ensure the sustainable management of shared water resources and to ensure peace and stability in the region, the role of women in Central America is subject to heavy patriarchal patterns. So the study highlights the opportunities at the regional and local levels to gender hydrodiplomacy in Central America through regional instruments and localized transnational networks. Gender and water diplomacy is a great opportunity to go over non-decisions and/or status quo at the national levels. Transboundary cooperation at the local level may give space to the prevention of conflicts at the regional level, therefore giving great importance to water diplomacy emanating from the civil society level. However, these opportunities also come with challenges, as local transboundary water politics generally reflect local power asymmetries, while regional norms highlight the shared values of cooperation. The implementation of norms decided at the regional level can therefore face some resistance due to the disconnect between localized forum-based discussions and regional inference-based norms. And gender can also be a component of these local asymmetries. So in conclusion, there is potential in regional instruments, such as the Central American Integration System, the CICA, to enhance regional and local female leadership. For instance, in 2013, CICA approved the regional policy for gender equality and equity. It has also shown an impetus with the creation of the Agenda for Sustainable Water Use in 2017. So the development, integration, and merging of both agendas is now the next crucial step to ensure an effective gendering of water diplomacy at all levels in the region. Furthermore, there is room and need for further research, especially to understand the challenges to local women leadership. And on-the-field research through interviews is actually planned once the sanitary situation improves. Thank you for your attention. I will gladly answer any question during the Q&A.
Thank you, Maureen. You showed clearly the importance of gender in water diplomacy in order to enhance sustainable transboundary water management, peace and security, not only in Central America, in the world. Finally, the last presentation of this session is made by Madhumita Chakraborty, who is research scholar at the Indian Institute of Technology, Kharagpur.
Hello everyone. Today I'm going to talk about understanding the hydrostratigraphic architecture of the Ganges River Delta and its control on groundwater arsenic distribution. The Ganges River is a transboundary river of South Asia and originates from the Himalayas and flows to the Bay of Bengal. Before meeting the Bay of Bengal, the river forms a wide delta mouth which is marked by the hatched line herein, and this is the area of interest for this study. The groundwater from the delta serves as a principal source of drinking and irrigation water for the inhabiting population. However, widespread occurrence of toxic levels of arsenic in groundwater pose severe public health risk and has been known to cause the largest mass pollution in human history. For this study, we have developed a regional scale hydrostratigraphic model of the Ganges River Delta based on 3,112 borehole lithologs assimilated from various public or government databases. The results show the occurrence of a continuous aquifer across the delta, which is known as the Sonarbangla aquifer system. This aquifer is underlain by a Gangaridai aquitard, Gangaridai basal aquitard, which forms an impermeable hydraulic basement below the Sonarbangla aquifer. The Sonarbangla aquifer also exhibits progressively increasing occurrence of discontinuous aquitards towards the active delta mouth, and these discontinuous aquitards are herein known as the Bhagirathi Hooghly aquitard. Now, based on the increasing intercalations of the Bhagirathi Hooghly aquitars, the delta aquifer system has been divided into three major aquifer subsystems from northwest to southeast. These are the type 1 aquifer system to the north, which is marked by a single continuous aquifer system. The type 2 aquifer system is a transitional zone between the type 1 and type 3 aquifer system and is marked by a vertically segregated semi-confined aquifer system. And the type 3 aquifer system along the active delta mouth is a multi-layered, nearly confined aquifer subsystem. A simple histogram analysis of about 1 lakh arsenic data point within the delta compiled from various governmental databases indicate that the percentage of arsenic safe wells are extremely comparable across all depth ranges within the type 1 aquifer system. However, within the progressively multi-layered aquifers of the type 2 and type 3 subsystems, the percentage of arsenic safe wells sharply increases with depth. Now, this is also manifested in the kriging maps, wherein the type 1 aquifer shows largely homogeneous arsenic concentrations across depth, while the type 2 and type 3 aquifer subsystems show sharp decrease in arsenic reduction with depth. The inferences of this study are as follows. The spatial distribution of arsenic is characteristically different in each aquifer subsystem. In the type 1 aquifer, arsenic concentrations tend to be homogeneous at all depths, possibly as a function of higher recharge under higher vertical hydraulic gradients, which results in inflow of arsenic-enriched groundwater and or surfacial organic matter into the deeper aquifer zones. In the type 2 and type 3 aquifers, arsenic concentrations sharply decrease with depth because the intervening aquitards act as a natural barrier against infiltration of the surfacial arsenic or organic matter-rich water to the deeper aquifer zones. Thank you so much.
Okay, thank you. Arsenic in groundwater is a general concern worldwide. Studies such as the one presented here will improve the understanding of its occurrence and will allow better decisions to be made for its correct management. Well, we have finished with the presentations and we have listened carefully to the different contributions. and views on the governance of transboundary aquifer through different approaches that represent a wide spectrum of disciplines that converge to put together the puzzle that is governance. Much remains to be done, obviously. We have no time left to answer questions. You can send directly to speakers through Huba application. And well, we are in time, so I want to thank the panelists for the important contributions, those who were present at this session for their interest in this topic, and the organizers for giving us the opportunity to be all here. Thank you very much to all. Good morning, good afternoon.
Thank you very much, Alberto Manganelli. So it was a very interesting session, a lot of examples. And now I will inform that the next activity will be the panel number 6, Transboundary Aquifer Experiences Across the World. What we can learn from each other. So that will be happening in 15 minutes. So I invite you to keep with us and keep this motivation. Really thank you all the panelists, all the attendees, and of course, Alberto, for your very nice sharing session. Thank you and see you very soon, 15 minutes. Thank you. Bye.
Thank you. See you.
Thank you. Bye. back after this short break from this very intensive day of sessions, very interesting. And now we are in the panel number 6 on transboundary aquifer experiences across the world, what we can learn from each other. And I would like to introduce and to thank Christina Fraser, researcher from the International Groundwater Resource Assessment Center, IGRAC, that I would like to give the floor and to wish a very nice panel session. The floor is yours, Christina.
Thank you very much, and thank you everyone for joining this panel. Welcome to all attendees. Today we have 4 distinguished speakers to assist us in discussing this interesting topic. Each will have 12 minutes to present the case study from the region that they are representing, and each have been asked to answer a specific opening question. And this question is, what are the enabling factors of transboundary cooperation within your region? And to follow up to that, if time allows, can you give us an example of actions within your region? Today, we also invite active participation from the audience, so you can ask questions to our panelists using the Q&A box online. And I also welcome you to, as our speakers present, reflect on the similarities and differences being presented about each region. So to not waste any precious time, I would first like to introduce Professor Sangam Strestra from the Asian Institute of Technology in Thailand, who will present the Mekong Valley perspective. Please, Sangam, you may share your screen and start your presentation.
Yeah, thank you, Christina. Good evening, everyone from Bangkok. So let me share the screen first. Okay, I feel very honored to present some of my insights of enabling and limiting factors of transboundary cooperation in the Lower Mekong Basin. In fact, my presentation is based on some of the projects I have been conducting now, and also some of the projects they have been completed in the Lower Mekong Basin. For example, one of the projects which is currently ongoing is strengthening groundwater governance in rapidly urbanizing areas of the Lower Mekong region, which is funded by Stockholm Environment Institute. And the aim of this project is to assess the current groundwater governance in 4 rapidly urbanizing areas of Laos, Cambodia, Thailand, and Vietnam. Similarly, I have been involved in several other groundwater related projects which have been implemented in the Lower Mekong Basin. And I was also fortunate to serve as a regional coordinator for Asia to assist the transboundary aquifer mapping of the Asian region under this transboundary water assessment program in 2014. So I'd like to share my experience based on these projects I have been involved in the region. But let me briefly introduce the Lower Mekong Basin. The Lower Mekong Basin is about 571,000 square kilometers and shared by 4 countries, Thailand, Laos, Cambodia, and Vietnam. And the basin is drained by the Mekong River, which is the livelihoods for the millions of people along the Mekong River. There are 4 geographic regions. They are Northern Highlands, the Korat Plateau, Tonle Sap Basin, and the Mekong Delta. The rainfall in the Lower Mekong Basin ranges from 1,000 millimeter in the Korat Plateau in Thailand and more than 2,500 millimeter in the highlands of Lao PDR. There are 4 main hydrogeological units in the Lower Mekong Basin. Along the eastern and southern eastern border of the Lower Mekong Basin, the hydrology is volcanic and granitic rocks with water-bearing features. Paleozoic meta-sedimentary rock with reduced porosity and permeability. In the northern part of the lower Mekong Basin, it has the porous and permeable late Paleozoic sedimentary rocks dissected into relatively small blocks by subsequent monogeny and topped up by the Mesozoic deposits, which supports the local groundwater flow systems locally discharges into the tributaries of the Mekong Basin. In lowland, particularly in the northeast of Thailand, there is a deep confined and shallow unconfined aquifers from the Mesozoic comprise of the sandstones. And in the Mekong Delta, it consists of the Cenozoic alluvial and deltaic sediments of up to 800-meter thick from both confined and unconfined aquifers. Let me briefly explain about the major transboundary aquifers of the lower Mekong Basin. Actually, the Transboundary Water Assessment Program has identified 8 transboundary aquifer systems in the lower Mekong Basin. And as I mentioned previously, that I was very fortunate to be part of this transboundary aquifer mapping program of the Asian region. So I will explain the 3 major transboundary aquifers of the lower Mekong Basin. They are Cambodia Mekong River Delta Aquifer, and this Cambodia Mekong River Delta Aquifer is shared by 2 countries, Cambodia and Vietnam, and it's about 180,000 square kilometer. The main use of the groundwater in this transboundary basin is for urban water and agriculture water. And in fact, the groundwater of this transboundary aquifer is heavily exploited for the urban water use in the Vietnam and also the Phnom Penh in Cambodia, as well as the agricultural cultivation in Cambodia and Vietnam. The second transboundary aquifer of the lower Mekong Basin is Korat Plateau Aquifer. And this Korat Plateau Aquifer is shared between Laos and Thailand, and majority of the aquifer is in the Laos. And again, the major use of the groundwater from this aquifer is for the agricultural cultivation, especially rice paddy cultivation and also the sugarcane cultivation. The another major transboundary aquifer in the lower Mekong Basin is lower Mekong River 2 aquifer. And this aquifer is shared by 3 countries, Laos, Thailand, and Vietnam. And the major use of the groundwater from this aquifer is for the domestic, agricultural, and industrial activities. Despite the significance of socioeconomic development in the transboundary aquifer region, there are several management challenges exist in the transboundary aquifer of the lower Mekong region. They are groundwater table depletion, saltwater intrusion, groundwater contamination, land subsidence because of the over-extraction of the groundwater, and also the absence of the legal and institutional framework, especially managing the transboundary aquifer resources. There are some of the examples of the challenges which exist in the transboundary aquifers of the lower Mekong Basin. And this is one of the examples of excessive water withdrawal and depletion of the groundwater table, and also associated land subsidence in the Mekong Delta. If you look at the figure A, this presents the average annual subsidence as a result of the groundwater extraction per 5 years. If you look at the groundwater, the land subsidence rate in 1991 to 1995, it's about 0.4 centimeter per year, but in 2011 to 2015, it is about 1.1 centimeter per year. Similarly, because of the over extraction of the groundwater, there is a depletion in the groundwater table and also associated land subsidence, which is evident in the figure B and C, which is of Kanto and Longan province in the Mekong Delta. Similarly, another management challenges in the aquifer is the arsenic, manganese, and iron contamination. If you look at these maps, these are the contour plots of the arsenic, manganese, and iron concentration measured in the groundwater of the Mekong Delta, which is again a transboundary aquifer of the Cambodia-Mekong River Delta aquifer. And it has been detected very high concentration of the iron. You can see that many locations, the arsenic concentration is more than 50 microgram per liter. Similarly, the manganese and iron concentration. Although there is no high-level cooperation for the transboundary cooperation in the Lower Mekong Basin, but there are considerable progress in the cooperation of the management of the transboundary aquifer in the Lower Mekong Basin. And I would like to describe three major enabling factors for the transboundary cooperation in the Lower Mekong Basin. One of them is existing regional institution. The second one is the third-party involvement, and the third one is the funding mechanism. There exists the Mekong River Commission, which was established in 1995, which is almost 25 years ago. And the Mekong River Commission was established to enhance the cooperation between the member countries, Cambodia, Laos, Thailand, and Vietnam. And the mission is to promote and coordinate sustainable management and development of water and related resources for the country's mutual benefit and people's well-being by implementing strategic programs and activities and providing scientific information and policy advice. In fact, Mekong River Commission has been providing platform for the several agreement for the water resources management, but especially for the surface water management under the framework of the integrated water resources management. Although there is a mandate of the groundwater management, but it has not been extensively considered. But because of the recent increase in the groundwater use in the region, Mekong River Commission has been implementing several projects and activities in the region to understand the groundwater resources, its utilization, and so on. So in the MRC strategic plan of 2016 to 2020, it contains plans to implement a set of activities to identify practical knowledge on surface and groundwater capacity and to evaluate the potential of the agricultural water use in the Lower Mekong Basin. The second enabling factor for the transboundary cooperation in the Lower Mekong Basin is the third-party involvement. And probably it's needless to say the UNESCO's contribution to enhance the regional collaboration among the member countries in the Lower Mekong Basin. In 2000, the UNESCO, ISP, and the IH, in collaboration with the FAO, UNEC, and IGRAC, initiated this internationally shared aquifer resource management program. And there have been several progress achieved in terms of the regional transboundary aquifer inventories, understanding the status of the groundwater resources, and engagement of the relevant national and international communities for the transboundary aquifer management. The third enabling factor for the transboundary cooperation is the funding mechanism. Recently, Jeff has awarded the project called Enhancing Sustainability of the Transboundary Cambodia-Mekong River Delta Aquifer, which is executed by the FAO. And The executing partners involve the Ministry of Natural Resources and Environment in Vietnam, and also Ministry of Environment in Cambodia, with several other stakeholders, with the objective to strengthen environmental sustainability and water security in the Lower Mekong Basin by focusing for the first time on improved governance and sustainable utilization of Cambodia Mekong River Delta transboundary aquifer. I would like to explain some of the enabling factors which further enhance the transboundary aquifer cooperation in the Lower Mekong Basin. They are the scientific research and the harmonious database development. Although significant progress has been made to identify the transboundary aquifers, but very detailed investigation is required to identify the hydrology, geology, connectivity of the aquifer system, groundwater availability, and its use. The second enabling factor to enhance the transboundary aquifer cooperation is the knowledge enhancement and institutional capacity building, because the skills, knowledge, and capability of the human resources are critical for the successful water resources management. And the third enabling factor can be the networking and partnership among the local, national, regional, and global communities. In fact, this conference is providing a lot of opportunity to understand and also to share the better management practices of the transboundary aquifer system, which is very, very beneficial for also enhancing the transboundary aquifer cooperation in the Lower Mekong Basin. So with this, I would like to stop my presentation, and I'll be very happy to take part in the discussion session. Thank you, Christina. Thank you very much.
Thank you so much, Sangam. A really interesting presentation of the Mihong case study and a really valuable insights, particularly for me, into the issues of water quality within transboundary aquifers and indeed intense areas of urbanization, because this is definitely a field within transboundary aquifer assessment that's still within its infancy. And there's clearly a lot to be done in terms of addressing these issues that you've spoken about, but it's also encouraging to see that there are still some enabling factors of transboundary aquifer cooperation within the basin. So I think we will move on to our next speaker, and I would like to introduce Professor Zoran Stevanovic from the University of Belgrade, Serbia, and head of the Center for Karst Hydrogeology. And he will present the lessons learned from the DICTAS project and represent the Balkans region more broadly. Please, Zoran, you may share your presentation with us.
Thank you, Christina. Hello, everybody. Good afternoon, good evening, good morning, wherever you are. I will present you the example of the project which been successfully completed in 2014. And we all expect that the new or second phase of this project will start very soon. According to information we have, it is already approved, this phase by the GAF, and supposedly to start in the early springtime next year. But I will talk here about the experience we obtained from this project. This is the area where is specific by the situation where the all started after the civil war was ended in the late 1990s, and where before Yugoslavia as a single country has split into the 6 republics, and in addition to Albania, which is a different country, the area and the study area was exactly in that part of the world, in the Southeastern Europe, in Balkan. So we have circumstances of non-regulated water management issues, in fact, and relatively weak monitoring despite relatively good knowledge of the local professionals. So this is the classical karst region for those who are less familiar. This is the area where science karstology, in fact, was born, where the Johan Cvic and his famous work and book of karstology been written in the end of the 19th century. So the area and the partners in the project was a 4-country in the region. As I said, 3 countries from former Yugoslavia, Bosnia and Herzegovina, Croatia, and Montenegro, in addition to Albania, which was not part of Yugoslavia. The Dinaric Karst is also involved a few other countries, Italy, part of Italy, Slovenia. In fact, the Kraso area is between these 2 countries, plus Serbia and Macedonia, which were not took part in the project. The full-size project of GIF was completed in the period between the 2010 and 2014 with the partnership of all the other countries, as I said, except those who are direct beneficiary of the project. The project structure was, in fact, and strategy included the 3 major components. That was transboundary diagnostic analysis, which is successfully completed during this 4 year. Then strategic action program, which is not completed, and it would continue to be in the 2nd stage. And the things that is not achieved and that is very difficult to be established according to our experience, this is this consultation and information exchange body. This will be exactly the task of the next phase of the project. In addition to, we had a very good stakeholder participation, consultation, and the communication. The implementation strategy was like that we had a 4 working group. The first one was the hydrogeological characterization. The second was the environmental and socio-economical assessment. The third one, it was legal and institutional framework and policies. And the 4th one was the stakeholder analysis. The area is not that large like a Mekong River we just learned from. For instance, we have just a population of the 3% maybe of that what we learned that living in Mekong, for instance, but this is still relatively, according to the scale of European country, is a moderate size, I could say. Amounting 90% of the energy production is coming from the water, from the hydropower. For instance, in Albania, Croatia is the highest hydropower installed capacity. GDP in the countries from agricultural sector is around between 8 to 18%. The industry from former Yugoslavia tradition was relatively well developed in iron, aluminium mining, and so. And what is important, the public water supply is with a large contribution of the groundwater in Montenegro and Bosnia. This is 90%. Similar in Croatia, and in Albania is about the 70%. Tourism is very important, especially along the Adriatic coast, and expanding in the last years. For instance, Croatia is running some 9.5 billion euro in the last years from the tourism. The area is very specific and very complex from hydrogeological and geological point of view. The karst aquifer, we not learn a lot during this conference experiences from such a region, because you have a very high precipitation rate, but most of the water is infiltrated into the ground in the some parts, in almost no any superficial flows. So we have also the large structure as a polye. This is the depression between the high mountains. And the largest polye in the world is exactly in that area, Livanjsko polje, with some 380 square kilometers. We have so many caves in the region. This is just a list from one of the country, from Croatia. I just use some sample examples to show you how complex area is. And here you can see the 8 names river. Why 8 names? Because the one same stream is permanently percolating down along the swallow holes and appears in the another springs. Water is oriented toward the Adriatic catchment and part to the Danube catchment over the north. This is very also specific groundwater flow pattern. Sometimes you need a very expensive tracing test to decide where the water, to define where the water flowed to. For instance, in certain places, we have recorded apparent velocity of the groundwater between 0.5 meters to even 0.8 meters per second, which is almost one waterfall in the ground. In certain areas, we have a real transboundary aquifer. For instance, this down left photo is the spring Ombla, which providing potable water to the famous touristic center Dubrovnik. But Croatian catchment is just 5% of the total catchment. All rest, 95%, belong to the neighbor country, to the Bosnia and Herzegovina, and you can imagine how complex could be to establish sanitary protection zone and the proper transboundary management. The area is rich with the groundwater. We have recorded some more than 200 springs with minimal discharge over 100 liters per second. Even the 100 of them has a discharge over 500 liters. And for instance, during the creation of the World Karst Aquifer map, you can see how the dense, this blue and the red dots, how the dense is the number of the large spring just in that area. So, meaning that one of the results is that you have a large fluctuation between minimum and maximum of the water. What we did in the project, as one of the first steps, we delineated most problematic the transboundary aquifers in entire Dinari Karst. Total surface area was about 10% of the total Dinari Karst. It is 12,000 square kilometers. And these 8 specific areas, transboundary aquifers, was under our main focus. For instance, here is just one example where you have the groundwater which is flowing between Croatia and Bosnia and Herzegovina. In 4 cases, the water is flowing from Bosnia to Croatia, and in 1 case, from Croatia to Bosnia. This is groundwater flow pattern is very complex, and in order to define and to characterize, we construct the specific inquiry tables. And we did one extensive collection of the previous information and also additional survey in order to make a proper characterization. Because what we all find that this is the task of the working group 1, hydrogeology, that in such a complex aquifer, we really need a proper assessment and the proper data collection and evaluation. So what is also the task of the second working group, environmental and socioeconomic analysis. We found also very good results of their analysis, plus of the legal and institutional framework and policy. What we found that there were some similar laws in the countries. It is simply results of that was one unique country in the past. And most of all countries, in fact, adopted European Union Water Framework Directive in the water practice and adoption of the water laws, which is also results of this framework directive. The main findings of the transboundary analysis was there were some challenges as a cross-sectoral coordination, the lack of the implementation of the integrated water resources management principles in the groundwater governance. There were also lack of the public administration capacity and understanding of the complexity of the hydrogeology and the public participation in decision-making procedures. What is the real threat to the groundwater? This is the inappropriate disposal of solid waste and wastewater, and the very vulnerable aquifer system, which is a typical characteristic of the karst. And there was also some negative consequences of the energy production and negative impacts to the ecosystem and environment. Some of the major achievements, for the first time, we created database in digital map, digitalized, and for the common region. We also ran a website, which was very important tool to communication. We had a large conference at the end of the project, which is in fact highlighted major findings, and it was participated by the number of the karst experts and also hydrogeologists. It was linked and supported by the Karst Commission of the International Association of Hydrogeology. We published a book about about this conference and also results of the Dinari Karst project. From the 2014, we started traditional course organized in the Bosnia and Herzegovina and partially in Montenegro. This is a course about the characterization and engineering of karst aquifer, which can be supported by UNESCO and also some other universities all over the world. During the last 5-6 years, we have more than 100 participants lectured every year by 10 professors from different countries, which are rotated every year. Just the last 2 years, we had, unfortunately, this problem with the pandemic situation. Finally, we have this strategic action 1, 2, and 3. The first is the lack of the monitoring, supposed to be overcome by the creation of the monitoring network. The second, we have to harmonize criteria for the sanitary protection zone. We have to also apply and promote the joint principle of sustainable management and equitable use. Here is the sum of the also action that we intending to apply in the second phase to strengthening somehow this awareness of the public and the local capacity building. We have to ensure sufficient quantities in the dry period, which is one of the tasks. And we have to develop and improve integrated river basin management plan and coordinate legal mechanism. As an experience, just a question at the end of our project was, do we have collect enough information about the aquifers? In such a complex system, you need a real support of the hydrogeologists and the professionals to create the background for discussion and for the policymakers and for the decision makers as well, and to develop and also to increase the local population awareness of the importance of the ecosystem and the water and the nature resources. I mean that this is a real need to implement the second stage of the Dictas project, and the creation of the thematic groups is also proposed, and they will work one water resources and ecosystem, another on the governance and legislation group, and finally capacity building and dissemination group. We also, in a project proposal for GIF, we defined the 5 major components, which are more or less, it is related to the governance of the groundwater and establish of the monitoring system, which will be support sustainable water use and ecosystem saving. Finally, transboundary funding, transboundary project was possible after the provided international funds. The second, professional team must resolve technical issues and create platform for water management. The systematic monitoring and exchange data is crucial. It was highlighted in many of the discussion during the last 2 days. And finally, the common institutional water bodies is needed, of course, but is somehow difficult to be established in the practice. So thank you, Christina. Thank you, everybody. Few minutes more, and I suppose will not damage so much our plans.
Thank you. And yeah, I'm already seeing themes emerging after these 2 case studies, particularly in the role of financing projects like the Dictas and being an enabling factor of cooperation, alongside the essential role of technical and a scientific basis for management and decision making. So thank you for that, Zoran. Before we move on, I would just like to remind the audience that they can pose questions to our panelists in the Q&A box online, and I very much encourage you to do so. Now we will move on to the Southern African region, where Luciana Skrinci, project officer from UNESCO, who's also heavily involved in the Greta project, will present the Stampriet Aquifer case study. Luciana, you may share your presentation with us.
Thank you, Christina. I'm trying to share my screen now. Slideshow. Yes.
Perfect.
Okay, well, thank you very much for having me today in this panel. I'm very happy to be here today to present the case of the Stampriet transboundary aquifer system. And hopefully I will be able to illustrate some of the factors and actions for cross-border cooperation in this aquifer. So yes, the Stampriet aquifer has a total area of over 86,000 square kilometers. It is shared by Namibia, Botswana, and South Africa. It is in a rather dry area, so there are no permanent rivers here, and groundwater plays an important role for livelihoods. The annual groundwater abstraction is around 20 million cubic meters, used for irrigation, livestock, and domestic use. And in here, I don't know if you can see my cursor, the last bullet point mentions that there is a multi-country cooperation mechanism established for this aquifer, and it is nested in the Orange Senku River Commission, or ASECOM. So this cooperation mechanism is the first example of institutionalized cooperation over a transboundary aquifer in the Southern African region. And that is why I thought it would be interesting to focus my presentation on this cooperation mechanism, because it is both the result of successful efforts undertaken by the countries sharing this aquifer, and also it's an enabling factor itself for cooperation in the future between these countries. So to get an overview of this cooperation mechanism, this slide what shows is the structure of ASECOM, which is a river basin organization which has a mandate to promote the equitable and sustainable development of the resources of the Orange Senku River. So ASECOM provides a forum for consultation and coordination between the riparian states to promote the integrated water resources management and development within the basin. So here what we see is the institutional structure of ASECOM. I think I lost my cursor. So the upper part of this figure shows that it is composed of a council, a secretariat, and task teams and committees. And the lower part shows the Stampriet multi-country cooperation mechanism, which is nested in one of the technical task teams, which is the Groundwater Hydrology Committee. So the objective of this cooperation mechanism is to enable and support the sustainable actions on the ground through activities related to the Stampriet. And in the short term, it does this by, first of all, continuing the existing characterization of the Stampriet, generating a flow of data and information between the riparian countries, and reporting on the activities that are related to the aquifer in each of the meetings of the Groundwater Hydrology Committee in ASECOM. It also has a long-term goal, which is to move from this role of data collection and exchange to providing a platform for advice for joint actions of the countries in the management of the Stampriet aquifer and its resources. So to answer the question, what are the enabling factors of transboundary cooperation in the Stampriet? And in here we can see some of them, which I believe they have enabled and still enable the cooperation between the countries who share this aquifer. So first of all, there have been multidisciplinary scientific studies, which were the cornerstone that informed the establishment of this cooperation mechanism through a joint understanding of the aquifer. And while this includes the hydrogeological characterization, the conceptual model, the knowledge about how the groundwater resources are used, the knowledge about the threats to the sustainability of the use of the resources, the different stakeholders, and the legal and institutional frameworks. So knowing these legal and institutional frameworks, it was also known that the laws of the the three countries which share the aquifer already regulate the abstraction and the pollution sources in the aquifer, and this makes for a good framework for addressing the main challenges faced in the aquifer. There is also a regional legal framework which provides a basis for the management of groundwater resources through the SADC Protocol on shared watercourses and the ASECOM agreement. However, they don't address specifically transboundary aquifers, and in the case of the Stampriet, they don't help recognize the importance of the transboundary nature of this aquifer for addressing the needs of preserving the quantity and the quality. So the three countries sharing the stamp-rates, Botswana, Namibia, and South Africa, recognized a need for a framework that could allow the development of specific rules to manage this aquifer. Well, there are a number of players who interact actively and cooperate in the region as partners, and this has built trust over time. And based on this interaction and on this recognized need for a specific cooperation framework for the stamp-rates, is that the countries were encouraged to propose the establishment of a cooperation mechanism to Orasecom. And finally, because of the institutional structure that I showed before, once the countries have decided to propose this cooperation mechanism, it was very easy to nest it in the River Basin Organization. And this means that it didn't take too much time to make it a reality. So since 2017, the cooperation mechanism is indeed nested in Orasecom. Okay, so some actions which support cooperation in the stamp-rates, and also the reason why I know about this case study, are the actions that were carried out in the framework of a project implemented by UNESCO and financed by the Swiss Agency for Development and Cooperation, which is the governance of groundwater resources in transboundary aquifers, a project that I'm happy to have seen in many presentations already in this conference. So this project uses an approach that is based on science and hydrodiplomacy to foster cooperation between countries sharing transboundary aquifers. It's implemented since 2013. And well, if you remember the previous slide, I mentioned there were assessments carried out, which helped build a shared knowledge of the aquifer. And the GRETA project supported these assessments through a methodology which is for multidisciplinary transboundary assessments developed by UNESCO and IGRAC. And this implied collecting and processing national data, harmonizing it across the three countries, and being able to make diagnostics on groundwater management issues and providing recommendations for improvement of governance. Then with the data collected, a joint database was set up. This is something also that we saw in the other case studies. And this facilitated the preparation of thematic maps and even the development of a groundwater numerical model for informing decision-making. And then all these results, which are rather technical, they were complemented with capacity building activities and trust building activities, which played with this already existing interaction between the partners and the stakeholders in the region that I mentioned before. So this is to foster cooperation and support this process of institutionalizing the cooperation between the countries. Then more recently, there was a development of a wide strategic action plan for the stamp-rates, which is aimed at providing a framework for joint management between the governments of Botswana, Namibia, and South Africa. So this plan considers previous efforts which were undertaken in the basin, including the basin level transboundary diagnostic analysis, the Orange Senku strategic action plan, and the national action plans of each of the riparian states. So finally, in the framework of this project, we are currently working with other river basin organizations. And we base this work on the lessons that have been learned throughout the years since 2013, and applying the same methodology for science-based cooperation, which is in the GRETA project, and taking as an inspiration the multi-country cooperation mechanism of the stamp-rates. So in conclusion, the joint development of knowledge about transboundary aquifers by riparian countries can foster their cooperation. When there are existing institutions which have a long-term a sustainable mandate, like river basin organizations, they can play a key role in institutionalizing cooperation for transboundary aquifers. And then this institutionalization can provide an advice to countries when they try to manage their shared aquifers. And to support this, a multidisciplinary approach based on science, capacity building, and trust building can be a huge support. So thank you very much, and I will be happy to answer questions if there are any.
Thank you so much, Luciana, for such an insightful presentation and really, yeah, a great example of multidisciplinary assessment, and the power that joint databases can have for providing a solid basis for cooperation. And also a really great example of transboundary aquifer cooperation being nested within a river basin organization, which I really hope we do see more of, particularly moving forward to achieve SDG 6.5. Finally, I would like to introduce Dr. Renee Gomez Garcia Palo from the Development Bank of Latin America and the Caribbean, Senior Executive and Head of the Green Business Unit, who will present the experiences from the Guarani Transboundary Aquifer. Please, Renee, you may share your screen and begin your presentation.
Thank you, Christina. And also, in behalf of CAF, I'd like to thank UNESCO for this kind invitation to this very important conference. Please, okay, great. Now we have on our presentation screen. Just let me begin sharing with you that CAF is the Development Bank of Latin America and the Caribbean and contributes to solve the structural aspects that impede the development of the region. This by carrying out activities to support, promote, foster, and strengthen the capacities of its member states, emphasizing the will to promote universal access to quality services in the areas such as health, water, and sanitation, which also requires the strengthening of scientific and technical knowledge on water and its services, and the development of solid economic, social, and environmental basis to support its governance. CAF, next, please. Just can we move on to the next? Okay, thank you. CAF as implementing agency, as an alliance with UNESCO, is about to begin an international water GEF, the Global Environment Facility project in the coming weeks. And this project is the implementation of the Guarani Aquifer Strategic Action Plan enabling regional activities. Should we go to the first one, please? Yeah, to the map. Is that possible? Okay, thank you. And now in the screen we have the Guarani Aquifer, which is located in the southern corners of South America. The Guarani Aquifer, one of the most important aquifers in the Americas, has an area of, larger than 1 million square kilometers, an estimated water volume of up to 37 cubic kilometers. And every time we see this map and the different locations of every aquifer, we see how, the very importance, the very strategic importance of these transboundary aquifers. As you may notice, probably, every country in America share somehow an aquifer. And the locations of this aquifer are very much, match the economical activities in which every country, has been developed. So the collaborative work towards, towards common goals and collaborative work oriented of every one of these aquifers is very much mandatory. So please go to the go to the next one. Throughout these presentations, I want to share a little bit about the main aspects of this project that we are just about to start. We are going to begin with the background, and okay, okay. No, I think we just jumped to the.
We jumped to the result.
To the very. Okay. Now, good. Thank you. Okay, and okay. Now we're good. First of all, like in any project, we need to identify the indicators in which we can somehow we can build a system or a very a most precise concept about the challenges and the gaps that we're going to face on. So I think every country, Argentina, Brazil, Paraguay, and Uruguay, who are the owners of this aquifer, they did a tremendous job during the last lag of the last century and the beginning of 2000s, engaged in a collaborative work to work towards the Guarani aquifer better knowledge and management. And I think most of these gaps and challenges have been identified, and this helped very much in order to measure and structure every enabling factors for cross-border cooperation in which they were working with. First one is to know in a very much scientific and integrated approach a hidden groundwater resource that was perceived as strategic for the socioeconomic development of the region. As every one of you, dear colleagues who precede me, you pointed out of the value of the scientific knowledge. And I think for groundwater, you see, this is very much true and very much, I mean, previous requirement for any or for their activity in which any kind of investment is going to be committed. The second one is protect the resource as long as it is now and promote its sustainable use, assess an integrated way the hydrothermal resource of all its potential uses, water, temperature, and energy, and prevent conflicts between countries over the use of the Guarani aquifer is very important because knowledge, transparency, and common goals and collaborative work they help to build the best, climate for a collaborative, to achieve these common goals in a very efficient manner. Fifth is agree on an action plan with a common strategy. It's the PEA. And I think everyone who's worked in international waters, they know the value of the PEA. The strategical action plan is very important because it's not only aimed or composed by hydrology or hydrogeology or hydraulics, but for a matrix which is built with social and economical important matters and investments. The next one, please. Okay, so this set up the background for the project that we're just about to begin, and this made several institutions before us, like the Organization of American States and the World Bank, and been working with Jeff funds in previous projects. Please keep going. Okay, as a result of this previous work, we are starting with, I think, in a very good position. But the only thing that we need to do, so far, is to update the different outputs and outcomes that this previous work has been achieved about between 5 and 7 years ago. But most of them are fixed and are very much absolute, like the aquifer size, limits, behavior, and flow mechanics. the age and quality of the waters, temperature and energy, and some of its most important ecosystem services were recognized. Anyways, I mean, you know that the value of the ecosystem services, those, I mean, these days, that help us a lot in order to come up and to design new financial instruments in order to help or to support or to add new very innovative ways in order to finance the different projects which are going to be identified within this coming, I mean, in these coming 2 years in which the project is going to be developed. Coherent advances and in the legislation of the countries were proposed and support was given to a regional agreement for the coordinated management of the resource. And I think one of the main goals that, I mean, that every one of these 4 countries have achieved and during the last year is the Guarani Agreement. There's been a lot of work. There's a lot of work behind this agreement, and I think it's a huge advance, which makes the current projects, I mean, a lot more predictable. Academic and institutional links were established. Important sectors of the society were sensitized, and there was coordination, pilot experiences, and border areas as a strategic action program. And this is very important, I mean, because most of these institutions, I mean, nowadays we find that they are working, and they are working very well, especially in every country. Please move to the next one. Well, the CAF, UNESCO, and JEF-funded project is aimed to update the strategic action plan, the PA that we just mentioned. After 7 and 5 years, we need to do this. Promote the role of women. That's very important. The gender analysis is going to be very much involved throughout the whole project. Consider the climate change scenarios and identify ecosystem services provided by the strategic by the Guarani Aquifer. All this line is comprised by the new agenda of sustainable development, and also very much aligned to NDCs, the Paris Agreement, the global biodiversity framework that's going to be, we hope, agreed by the beginning of the next year, and the SDGs. We need to align every new initiative and every new project to these very much important guidelines, global guidelines and country guidelines. Deepens involvement, the participation of different stakeholders, the academic sector, the private sector, and social organizations. This is a very important point to include the private sector as a main actor of every new initiative. And bridge project that follows up and seeks the implementation of what has already been agreed, and its project with a strategic focus towards the common future. So the transboundary impact in every project needs to be identified, needs to be validated, and needs to be agreed by every of these 4 countries. So any project, in spite is located in one country, needs to have a transboundary impact so they can build ownership among the whole, the whole concept of the project. Let's go to the last one, please. The key role of CAF means joint efforts with Brazil, Argentina, Paraguay, and Uruguay to advance together in these key activities. And its role simply, CAF is an implementing agency, as we just mentioned, in alliance with UNESCO as executing agency. And the project seeks to consolidate the scientific and integrated knowledge, the transboundary groundwater technical cooperation, the regional institutional framework, and the monitoring and modeling, which is very important to leave that in place and with the necessary institutional framework. And finally, CAF is aiming to continue supporting every project very much aligned, as we mentioned, to the NDCs, the global biodiversity, the global framework for biodiversity and SDGs. So CAF as the Green Bank of the Latin America and the Caribbean is looking forward to begin this project as soon as we can. Thank you.
Thank you so much, Renee, and some clear messages there in your presentation about the important role of these projects in supporting assessment, strategic planning, and cooperation in the region, but also something that hasn't really been touched upon much yet within this panel, which is conflict mitigation as an enabling driver to encourage transboundary aquifer cooperation, a really important point that you made there. Thank you. I think we've unfortunately run out of time now, so we're going to start to close the panel. However, if there's something that you would like answered or you would like to engage with panelists further, I would encourage you to message them on the interactive conference platform that we have. I'd just like to offer some short reflections from what's been discussed. This afternoon, we've heard from 4 speakers from 4 different regions of the world. And indeed, experiences do vary, but we can also see similarities in these case studies. And we can take lessons learned from these experiences and apply them to our own work. Financing and a sound scientific knowledge are clearly essential to enabling cooperation. However, these are futile without a mandate, willingness to cooperate, and strong institutional frameworks in order to implement these. Finally, let's not wait for another decade for the next ISARM conference to share our experiences and learn from each other. Let's find new ways to share these valuable lessons. And I therefore encourage you all to continue this dialogue started at the ISARM conference, share the progress being made, and continue to learn from the experiences of others and other regions outside of your own. Thank you very much, and I hope you enjoy the rest of the conference.
Yeah. Thank you very much. So just I would like to inform and once again, Christina, Fraser, and all the panelists, attendees, thank you very much for your questions, your participation. And now I would like to announce the last activity of today, the session number 14 on advance in the assessment of mapping of transboundary aquifers and hydrogeological methods. So we can meet again in 15 minutes in the same room. So thank you and see you again very soon.
So
not least session of today. And as previously I mentioned, so it was a very active day, a lot of interaction. So thank you all the attendees. And again, I would like to thank you this new session and the panelists. That this new session, the title, it's Advances in the Assessment of the Mapping of Transboundary Aquifers and Hydrogeological Methods. So session number 14. And this session will be shared by David Kramer. He's the president of the International Association of Hydrogeologists and professor of the Geoscience University of Nevada, USA. That it's a pleasure to give the floor. And so you can start in the session. Thank you very much to you and everybody.
Thank you very much. I'd like to welcome everyone to session 14 of the Transboundary Aquifer Conference. We are privileged to have a wonderful lineup of speakers for this session, and certainly it's a varied session. We have many different perspectives that I think will be interesting to the participants. And so without further ado, I'd like to introduce the first speaker. The first speaker is Leticia Rodriguez. Leticia is a professor at the Universidad Nacional del Litoral, Argentina. And her topic will be a new regional numerical groundwater flow model of the Guarani aquifer system, and should be a fascinating talk. The floor is yours, Leticia.
Thank you. Well, good afternoon, everybody. Thank you for your introduction. I'm presenting this work on behalf of my co-authors, and most of the results that you will see are included on Andres Mira's doctoral dissertation. Where is the Guarani aquifer located? It is in South America. It is shared by Brazil, Paraguay, Argentina, and Uruguay, and it extends for over 1 million square kilometers. It sustains the groundwater use of more than 90 million inhabitants, and the groundwater storage is estimated within a huge range between 25 and 40,000 cubic kilometers. It receives an average precipitation of 1,500 millimeters per year, though with a strong gradient from north to south, east to west. The population, industrial, agricultural, and recreational activities are expected to grow in the future. As an example, I just highlight, for example, the extension of agricultural soil from 22% of the area to 47% in a 35-time window. I have to say that this aquifer is underneath the Rio de la Plata Basin in South America, one of the largest surface river systems in the country, in the continent. In terms of the geology, it is located on the Paraná and Chaco-Paraná sedimentary basins, filled with volcano sedimentary fill that reaches 7,000 meters in deep. Mainly detrital sediments with numerous intercalations of dikes and basaltic flows compose the basin. Some of the main regional structures that influence the hydrodynamics are the northeast to southwest central hollow with a very deep basement, large arcs and synclines such as the Ponta Grossa arc here on the right in Brazil, and further south, the Asunción Rio Grande arc, a large synclinal structure here in Argentina, Paraguay, and southern Brazil. As you can see on this cross-section, the aquifer is mostly confined by thick basalt flows, except along its borders, where it outcrops here on the left. On this very simplified stratigraphic chart from the Paraná and Chaco-Paraná basins, I just highlighted in red the formations that each country identifies as belonging to SAC, Misiones, Tacuarembó, Botucatu, etc., depending on the geological terms of each country. From the hydrogeological point of view, there has been an evolution of knowledge over the past 40 to 50 years. The first piezometric map was put in place in the 70s. As you can see, it's very sketchy, based on very limited data, but it identifies the first flow lines from north to south and some flows from west to east. 20 years later, Araujo extended the study area and identified flows coming from outcropping areas highlighted here in green towards the center and then towards the south. A few years later, Campos deepened the study of the hydrogeological system, confirming the role of confining layers into the behavior of the aquifer. Finally, within the project for the Guarani aquifer system, the latest piezometric map was put in place after a decade of collaborative work between technicians of the 4 countries with the cooperation of international agencies. And the product of this project was a better delineation of the limits of the aquifer, a better defined piezometric map, and the proposition of a sectorization in 4 compartments according to the hydrochemistry of the groundwaters in the aquifer. In parallel, there was the development of numerical models. The first one was built 20 years ago and included only the Brazilian sector, built on limited level data. Later, it was expanded to the full extent of the aquifer. Always the aquifer on those 2 models was a single layer model. In Paraguay, with the support of the German Geological Survey, Paraguayan technicians built a much sophisticated model. It's a 5-layer model, but limited to their sector. And the latest exercise was by Nidman, who also, besides the flow simulation, extended into some grow age preliminary simulations. In spite of this build-up of knowledge over the past 30, 40 years, still there were strong hypotheses made concerning the behavior of the aquifer. And those were that no vertical flow between pre-sack sediments, sack sediments, and post-sack layers was considered. There was uncertainty about some discharge areas. There was no effect of major structures in piezometry and sack thickness being considered into the conceptualization. And on the Argentinian side, they were concentrated the great uncertainties. Why? There was little knowledge about the thickness, extension, and relationship between the aquifer, the confining serrageral basalts, post-basalt sediments, and the basement. The piezometry was quite uncertain, and the groundwater discharge into Esteros de Liberá, which is the largest wetland in our country, was postulated with some evidences of mixing waters, but still there was not certain. So all these highlighted uncertainties motivate us for a new study. So what we did first to start with the geology, focusing on Corrientes province within Argentina, and we integrated new well logging information. We conducted a new 40-kilometer magnetotelluric profile, and we developed a 3-dimensional gravimetric model. The integration of these 3 groups of information allowed us to compose a 3-dimensional geological model within Argentina that highlighted the complexity of the geometry underneath a very flat terrain that is composed of 5 layers, including the basement. The average thickness of the aquifer in our area is 115 meters, but the sack is wedging toward the west, and that gave us the way to postulate a new southern limit of the aquifer as compared to the PSAC project. We also revisited the piezometric information. Basically, the main change was at the center part, there's some flows discharging into the west as opposed to the previous version. In terms of the hydrochemistry and isotopes, we conducted intensive field data campaigns collecting groundwater data and surface water data all across the southern sector. And with those samples, we analyzed for major components, stable isotopes, radiocarbon, and at selected sites, the presence of dissolved noble gases as helium-4 and krypton-81. The analysis of stable isotopes and hydrochemistry led the experts on this issue to find mixing trends within our area. Trend composed of recent groundwater and to oil components that the interpretation was attributed to sack waters and pre-sack waters underneath. Of course, the ideal distribution of those mixing zones were influenced by geological issues at the local and regional levels, such as the presence of arcs, the thickness of the different layers, and fault areas, plus the combination with piezometric differences in the vertical sense that could favor upward flows in presence of faults. With all this new knowledge, we postulate a new conceptual model composed of two layers, the sack itself and a surface layer, and both connected through basalts. And for the first time, besides the recharge occurring only along the outcropping areas of the aquifer, we consider a very narrow strip of fractured basalt as potentially providing recharge to the underneath Guarani aquifer. The conceptual model was tested numerically with the transient finite element code. This is, as you can see on the left, this is the complex mesh that we built up with an average size of elements of 36 square kilometers, pretty good for a regional model. Here at the top center, you see the complexity of the surface drainage network that provide us the stream aquifer interaction with the deep aquifer and the top aquifer, where they, of course, overlay. Here at the bottom, you see the zones of hydraulic conductivity resulting from the automatic calibration of the model. On the upper right, the distribution of recharge zones, putting into the model close to 20,000 cubic hectometers of water. And down here, the distribution of close to 2,000 pumping wells that, of course, increase their pumping rate as we evolve in time. The calibration strategy was as follows, after selecting, of course, calibration points according to their data reliability, we conducted two simulations, one under steady state conditions with no pumping, and a second one spanning over a period of 30 years from 1968 to 1997, using a monthly time step. And I'm showing here some of the results. Here you see the comparison between observed and calculator levels. Overall speaking, the agreement is good considering that we have groundwater levels from close to 50 meters to over 1,000 meters. So the average residue was 27 meters, distributed as follows in this low left picture. In some places, we had a very good agreement. In some other places where pumping wells are concentrated, we had a little bit of trouble for calibration. In general, the groundwater pattern, regionally speaking, is very well reproduced by this new model, as you can see here on this color picture. And on the left, I just extracted 3 well hydrographs, 2 the upper and the lower one on the outcropping areas. You can see, of course, the fluctuation, the response of the levels in response to recharge and stream flow differences. And on the middle, you see the confining part of the aquifer, of course, completely stable levels. And at the end, you see the only data we have for comparison purposes during the transient period. Of course, you don't have to go into the details of these pictures. I just want to show you one of the components of the mass balance, which is the interaction between the groundwater system and the surface water system. Is very complex because of the complexity of the drainage network in the area. The conclusion was that the discharge of the groundwater system into the streams is very small and is comparable to base flows in some small streams. Finally, when we look at the storage, groundwater storage, you can see here, of course, over the 30-year period, years with input of water into storage and depletion of water from storage. When you accumulate those values, you see that over the past 10 years of the simulation, there is a clear declining trend. How much is the system declining overall speaking? About 14 millimeters per year. And that number is very comparable to independent estimations made using great satellite mission performed by different authors in the area. So finally, I just highlighted a few findings in red. The model was the first one who considered the SAC interconnected with confining units on top through the basalt layer. Second, the small amount of discharge into the main streams of the system makes very difficult to corroborate with independent estimations the value of those estimates, but still we know it's very small. How much pumping is occurring? Well, so far it's about 8.1% of the model discharges. And finally, like I said, from the 90s, the depletion of the aquifer is occurring, and it's equivalent to close to 16 cubic kilometers per year. Finally, I would like to highlight some of the key issues identified in a consultancy meeting convened by the International Agency for Atomic, the Atomic Agency, that was held in Vienna with technicians from the two countries, the presence of CLISBOS and of course, local technicians for the agency. We identified still many hydrological uncertainties, the response of the SAC to historical and future water extractions and expected impact of climate change on precipitation, runoff, and groundwater recharge is a big unknown yet. And of course, in terms of the management, how much water is available. So we hope to continue working on this as a collaborative team between technicians of the 4 countries, putting together the new isotopic information with new modeling, conceptual and numerical modeling. And with such, I thank you for your attention with Andres' picture, the main author of these results. Thank you very much.
Thank you, Professor Rodriguez. A comprehensive review of the Guarani aquifer system, its importance, the uncertainties, and the modeling, approaching great detail and step by step. I've never seen somebody conduct such a thorough workshop of groundwater modeling in 15 minutes. Thank you very much. Our next speaker.
Thank you.
Our next speaker.
I hope you understood something.
It was great. Those of us who do modeling really appreciated your thorough approach. It was a great presentation. Our next speaker will be Christian Navarez. Christian is from the Tecnológico de Monterrey School of Engineering and Sciences. His topic will be understanding the current and future groundwater pressures for transboundary, the Capilina and Concordia aquifer system in Peru and Chile. The floor is yours.
Thank you. I will share the screen. Good afternoon. I am Christian Narvaez, and I will present this work that was done based on my master thesis, and it's titled Understanding the Current and Future Groundwater Pressures for the Transboundary Capilina Concordia Aquifer System. And this work was supervised by Dr. Jürgen Marnech and Dr. Juan Antonio Torres. I will start with the general information known by UNESCO IHP program. This transboundary aquifer is located in the hyper-arid desert of Atacama, which has little precipitation and few sources of surface water. The aquifer is overexploited in Peru mainly for farming, and also seawater intrusion and soil mineralization problems have been identified. Currently, there are no international treaties in relation to the transboundary aquifer in terms of water management. So my master thesis objective was analyze the anthropogenic pressures on the transboundary Caplina-Concordia aquifer, integrating the hydrogeological information of Peru and Chile through a groundwater flow model. The model was focused on the most productive part of the aquifer system, that is the coastal plain, but the integration of the knowledge was at basin level. And at basin level, there were identified an artificial and natural connection with the Titicaca transboundary basin. For the coastal plain, a recharge of about 60 cubic hectometers per year has been estimated. Peru began to extract water in 1960 until in 2019 was registered an extraction of almost 200 cubic hectometers per year. Meanwhile, Chile began its extraction in 2012 with about 3 cubic hectometers per year. And in the coastal plain of the two countries has been identified high levels of salinization in the water samples. As I mentioned, the most productive groundwater formation of the aquifer system is the coastal alluvial fan here in light blue that concentrates more than 1,000 water extraction wells used mainly for farming, and only about 20% of these wells have water rights. This part of Thames is recharged mainly by a natural river called the Caplina River and by an artificial canal that comes water from the transboundary Titicaca basin by interbasin water transfer. And this canal crosses partially through the Chilean territory before it's discharged in the Uchusuma River in the Peruvian basin. The flow model that I made is bounded by the zone around the coastal plain, which has most of the alluvial fan and concentrate the water extraction. For this, we integrate georeference and data of the two countries to create a simplified 3D hydrogeological model. And based on this, we create the groundwater flow model that was calibrated with the last 20 years, and we made forecasts until 2040. We also integrate the groundwater samples, chemical data of the 2016. For the aquifer system forecasts were made based on some alternatives established on the Peruvian Water Authority management plans. We generate 4 management scenarios, including the business as usual, one alternative or increase the interbasin water transfer, one alternative of the improvement of the irrigation system in the Peruvian side, and the integration of the last 2 alternatives. The 4 management alternatives were crossed with 2 climatic trends, obtaining 8 forecast scenarios. As the main result, a new hydrogeological conceptual model of the transboundary aquifer system was obtained. Also, we got a 3D hydrogeological structure and a groundwater flow model of the focus areas, and this new knowledge can supplement the information of the ISARM project. Regarding the groundwater flow model results, the aquifer system has been depleted about 7 meters in the last 20 years, and is expected the groundwater level depletion will be between 0.2 and 0.4 meters per year in the next 20 years, considering all the 8 scenarios. These are historical and forecast water level depletion trends of 6 selected points on the domain. Based on the flow model approach, we could follow particles from the seawater boundary through different years. With this, we could infer the extension and dynamics of seawater intrusion for the past and future 20 years. With this, we could infer as a complementary data, we present the salinity map based on water samples of 2016 that shows high levels of salinization in the seawater extension marked by the model in that period. Some of the conclusion and implication of this work are that there is a connection, natural and artificial connection with the 14th Titicaca transboundary basin. Groundwater level depletion will continue to drop between 0.2 and 0.4 meters per year. Seawater intrusion will be 5 times in the next 20 years than in the previous 20 years. And 3 problems are related to the aquifer management. The fear is that part of the recharge comes from another transboundary basin, and there is currently a social resistance to new projects that seek to increase the interbasin water transfer. Second, there is a high level of overexploitation in the Peruvian coastal plain, mainly for farming, and only about 20% of the extracted volume has water rights. So to reach a stable condition, the exploitation of the aquifer system volume will have to be less than 40 hectometers cubic per year. And the recovery of the aquifer requires the real integrated management of all the stakeholders. Among the future works that can be developed in the study area is integrate the physical description, this physical description with a social and political description in order to define the hydrosocial territory. This model could be socialized with different stakeholders. So far, the model results were presented to Jorge Basadre Grohan University in Peru and to the National Directorate of Borders and Limits of Chile. Also, it could be simulate multiple scenarios based on real and possible cooperation alternatives between the two countries. All the information and reference can be found on my master thesis, and also we publish the outcome of this work in an open access paper. These are institutions and companies that sponsor my master thesis degree. Also unpublished data of the two countries were obtained from University Jorge Basadre Grohan University in Peru and the Water Directorate of Chile. I will be happy to answer your questions from Cuba. Thank you for your attention.
Thank you very much, Christian, for an excellent presentation. The Atacama, of course, is one of the driest, the driest area in the world. It has increased extraction of groundwater and high total dissolved solids, but the conceptual updates and the modeling has a great potential to help international cooperation. So thank you very much for your work. It's very much appreciated. Our next speaker, yeah, thank you. Our next speaker would be Claude Suaveplain. Claude is a former UN Interregional Advisor on Water and a UN DESA retiree. We're privileged to have him with us. His topic will be aquifer testing while drilling advances to characterize leaky shared systems. The floor is yours, Claude. Is Claude not with us yet? There you are. Thank you, Claude. The floor is yours. You're on mute. You're muted. You need to unmute.
Unmute. Sorry, I'm not too. Okay, unmute.
You're unmuted. We can hear you now.
Okay. Could I have my slides or they are not there? Should I load them?
If you have them, you can load them. Yes. Then you can share your screen and put full screen.
Where do I load? I can load out as of here now?
Yes, it's the green button in the middle, share screen.
Okay. Sorry, it's not coming. I sent them to you. I thought they were coming automatically, but maybe not. Eh? You don't have them?
I have them. I can share, no problem.
Yeah, thank you very much, because it's... I'm sorry.
You can move forward. Your mic is mute, Claude.
My talk today is a little bit intense. Mathematically, I apologize from the beginning. I have prepared that together with an hydrogeologist from Burkina Faso, Nestor Fiacre Compaoré, who is working intensively in the Taoudeni Basin, the portion of Burkina Faso. And we will take this sub-basin as an example of what could be done with regard to my talk. So it will be a trivial thing to say that in the majority of the shared hydrogeological sedimentary basin, there is no coincidence between the three-dimensional boundary conditions of these systems and the administrative limits of the territories. And we can expect more and more with the coming of climate changes that the sources of conflict, one of the sources of conflict between countries, will be evolving around consensual method and results to characterize the long-term safe exploitation rates of deep boreholes in order to avoid interferences across borders. Meanwhile, the groundwater resources in each side of the country are being mined. This is typically the case of the Taoudeni Basin, where the rates of recharge are typically low, and especially when we are dealing with aquifers at more than 300 meters depth. So in order to characterize leaky systems, leaky aquifers, that is essentially one aquifer separated by one or two aquitards, aquitards being less permeable layers, Antouche has proposed a model in 1960 to evaluate the results of pumping tests carried out in such a system. It's known as the beta model, and as you see, that beta is defined as the radial distance divided by 4 times the thickness, and the respective products of the aquifer, hydraulic conductivity, and specific storage divided by the hydraulic conductivity and the specific storage of the aquifer being pumped. And it's the square root of this ratio. So the drawdowns in this model are neglected in the non-pumped aquifer overlying the aquitard. This is a limitation because we know by experience that when you pump in a given aquifer and there is an aquitard which is not too thick in between, then there are drawdowns in the upper aquifer which is not being pumped. To correct this problem of the Antouche model, Newman and Witherspoon have proposed the fully two aquifer system solution. But to make the problem tractable, they have assumed that the vertical gradients in the non-pumped aquifer above the aquitard are negligible. This postulates an uniform drawdown throughout the thicknesses of these units, which can be the case if they are relatively thin. In my PhD thesis in 1987, I have proposed the three aquifer system solutions. That is to say, one aquifer being separated by two aquitards from another aquifer. And this is based on the same assumptions as Newman and Witherspoon. But I have, in addition, proposed an easy way of computing the families of type curves using a numerical inversion of the Laplace transform solution. So I will explain a little bit further what this means. So to solve an initial boundary value problem, IBVP, you really end up with a partial differential equation, initial and boundary conditions. It is suitable to transform this into the Laplace plane that works on the time parameter, and you will get a solution in terms of an ordinary differential equation. By applying the Hankel transform to this ordinary equation, you obtain an algebraic equation that you can resolve. So we get an image of the real solution through two successive transforms. Now you have to go backwards and do the inverse transform from the Hankel Laplace plane into the Laplace plane, and then from the Laplace plane back to the real plane. So this last part is really usually very complicated. The image solution can be obtained rather easily from the Hankel transform to the Laplace plane solution. But the last part is usually very complicated, and it doesn't lead to closed form analytical forms that can be easily computed. So this is an example of the type curves that we obtained for the three aquifer leakage system. And I will refer you to my thesis to understand a bit better how this works. But the most important thing here is that the dimensionless drawdowns, the SDs on the ordinate scale, are not showing a full stabilization. That is, the drawdowns in such a system will remain in unsteady state. That is, there is no stabilization of the drawdown. Although it looks like it, it's a pseudo stabilization, and this will create a problem if you don't take this into account. So, which the three aquifer leakage system takes into account. So it is also a truth that most of the sedimentary basins are showing to be leaky systems. Sometimes they could be fractured with double porosity type of situations, but the most general case is leaky systems. And if you want to evaluate the long-term safe exploitation rates, it has to use modern techniques of logging, testing, and in order to get the best possible evaluation of the hydraulic connectivities and the specific storage for the individual layers, be they aquifers or aquitards. This necessitates at least 2 rigs that can drill at the same time deep producing wells and observation wells. So on each side of an administrative border, there is a need to have a clear methodology that will apply these techniques for well and aquifer test analysis in order to reach comparable results. And if not, it will be difficult to reach agreements on long-term monitoring and respect of safe exploitation rates. So it has to be coordinated between countries in the memorandum of understandings that we're going to use similar techniques to arrive to similar results. And those results will then be can be put into the memorandum of understanding. It might look costly, but it has to be seen as an investment. So modern packer and logging techniques usually being used in the oil industry have been now transferred to the hydrogeological arena, and it's possible to isolate and measure drawdowns within the same intervals in pumped and non-pumped aquifers and leaking aquitards during long-duration aquifer tests. Drawdowns are typically undergoing, as I said, pseudo-stabilization phases in both the 2 and the 3 aquifer systems. It is important not to limit the test duration to a typical 72 hours, but to capture enough points on the drawdown curve of a given observation well in order to find the best match with the available family of type curves. Doing that, you will be able to characterize more than one hydraulic parameter for more than one unit, aquitards or aquifers. Another thing that has struck my mind is the current use doing step drawdown tests in well tests of this continued pumping rates, change of pumping rates without waiting for recovery between each step. And again, this is something that should be discontinued in my view, because it's very difficult to do an accurate interpretation of such tests given the interference aspects from one step to the next. So these are examples of techniques, methodology that should be unified and kind of accepted by everybody. In order to improve the knowledge of the Burkina Faso part of the Taoudeni Basin, the program called PAEA, which is a water supply and sanitation program financed under a loan of the World Bank, has devised a very ambitious drilling and testing program. It's composed of 14 boreholes of 500 meters each. Each of these boreholes have 14 observation wells at the same depth, and 2 deep boreholes trying to reach the basement between 1,000 and 2,000 meters. This would hopefully characterize the entire multi-layered system. I should say that there will be also a wealth of geophysical measurements, 800 kilometers of magnetic and electromagnetic measurements, 100 kilometers of electric measurements, 400 kilometers of seismic reflection. All of this should constitute the basis for the best localization of the exploration boreholes and their observation wells. I refer to you to the presentation of Justine Thirogo on the PAEA, which is a poster presentation, and also to the excellent talk of Malundana's Succès Koutanglia on the current knowledge of hydrodynamics in the Burkina Faso hydrogeological basin. In the Taodendi Basin, there is typically a succession of conglomerate sandstone, conglomerate sandstones, often fractures and argillites that constitute the material of the aquithards. Application of the two, or better the three aquifer system type curves for analyzing the drawdowns in the observation wells of the producing units and deducing aquitard parameters requires a careful strategy in the well completion, in the pumped and unpumped aquifer, and in the monitoring of the relevant observation wells. Research borers will also be transformed into producing ones, taking advantage of the results of the less expensive three aquifer system analysis, which taps more than one aquifer at the time, which measure the drawdowns in more than one aquifer at the time. So I will conclude with this slide just to give an idea of what I mean by safe exploitation rates. This is a local radial flow problem. And so I suggest that we should first define the time, the duration time of, because we're going to stay in transient conditions for years. So define first the time of reference for the exploitation rate, say 10 years. So you call this Q10, and an available drawdown, it's the maximum drawdown that you would admit for the aquifer that is being pumped, or the series of aquifers that are being pumped. So this is usually taken as 2/3 of the thickness of the aquifer. And I'll define the 10-year exploitation rate in that case by that formula, 4 pi kh, with the same k and the same h as before, the available drawdown. And then all of that is divided by a function that is deduced directly from the type curve analysis of the aquifer test. And with it's a leaky dimensionless expression that you obtain from the type curve in the match of your available drawdown and the type curve that is best describing your system. And the value of TD is the aquifer diffusivity times the 10 years time divided by the square root of the radial distance to the well. Usually we take 1 meter for defining a safe exploitation rate. Thank you very much for your kind attention.
Merci beaucoup, Claude. Nous avons une grande appréciation pour votre présentation. The Taodendi hydrogeological basin in Burkina Faso and Mali is a very important one, and your modification of the Newman-Witherspoon leaky aquifer equations is very well taken. Also, the mention of Packer systems and the limitations of step drawdown tests, I think, are instructive for many people. And as some of the previous speakers have mentioned, the importance of field verification as we go through this is a very important point. So thank you again for your presentation. Very much appreciated.
Thank you.
Our next speaker, actually, unfortunately, Rudo Rossetto is ill. So very graciously, we have had one of his colleagues come by to fill in. Enzio Cretas will be our next presenter. Thank you, Enzio, for being so gracious as to fill in. I'm going to let you introduce yourself and your topic. So the floor is yours, Enzio. Thank you again.
Thank you, David. Thank you very much. Let me share the screen. And please let me know if you see my presentation. Hello?
Yes, we can. We can see your presentation.
Okay,
thank you.
That's fine. Okay, well, I have only one slide, so I think that I will be on time. Basically, this work is focused on framing the state of the art in the use of digital tools in Africa. Just to give you some background, this kind of work has been conceived in the framework of a European Commission funded and Italian cooperation co-funded project focused on the Wi-Fi nexus assessment, the water, energy, food, and ecosystem nexus in the transboundary Senegal River Basin. And somehow it benefited also from other activities, few of them still ongoing, and particularly a large project named the ISWAT2, the second phase of the African Center of Excellence in Water project, which is a project funded with 6 million euros by the European Commission, implemented by the JRC in collaboration with UNESCO EHP, being mainly focused UNESCO on the human capacity development component. So at some point, both in the framework of the Senegal Transboundary River Basin project and more largely in other initiatives in Western Africa and the mentioned project ASWAT2, it became more and more evident that we would have needed to have an overall picture of the status of advancement in the use of digital tools. Particularly, I would mention activities that are currently ongoing in the Senegal River Basin, focused on water quality assessment, mainly in water, but in soils, in sediments, and in biota as well, in fish and in fishes and terrestrial animals on one end. The main beneficiary being envisaged to be OMVS, l'Organisation de Mise en Valeur du Fleuve Sénégal, and the other country partners sharing the basin. But I would also mention activities that we have been implementing in the framework of the ISWAT2 project over the Zambezi River Basin to support and somehow focusing on the priorities identified by the ZAMCOM, the Zambezi Watercourse Commissions, and other activities that have been implemented both in the Lake Victoria region and in the Blue Nile, involving both the Ethiopian counterpart upstream of the Gerd, the great Ethiopian Renaissance Dam, and downstream the Sudanese colleague. So basically the activity that has been implemented, this specific activity that has been implemented in collaboration with Rudy Rossetto from the Scuola Superiore Sant'Anna di Pisa in Pisa in Italy, was really focused on an overall assessment at continental scale of the role of digital tools, and particularly of the groundwater flow and transport modeling tools. More than 800 questionnaires have been distributed once main experts have been identified, mainly starting from the evidences from the published peer review journals, and more than 200, actually 230 questionnaires have been returned back and provided the basis for making an overall analysis. So what I will do in this presentation will be simply to remember the main outcomes of this analysis, as a paper that will address the specificities of this research will be soon published. Of course, it's quite obvious that groundwater resources are key worldwide, and particularly in Africa, and I will not focus anymore on that. It's extremely clear that there is a huge lack of expertise. And there is also a huge lack of data, or even where this data are available, there is often there are often quite huge difficulties in assessing this data. Just to mention an example, we spent more than 1 year and a half in order to finalize an agreement for assessing the data in the ZAMWIS, the ZAMCOM water information system. And we spent quite a lot of time as well in Southern Africa in order to have access to the SADC GMI, the Groundwater Management Institute database. And this applied, of course, not only to us, but also to our colleagues, African colleagues from the University of Western Cape, from the University of Gaborone in Botswana, from the University of Zambia, as well as from the University of Zimbabwe. Of course, there is also in parallel a huge need for tools that would enable to conduct this kind of analysis, and this particularly applies to groundwater flow modeling and transport, with a great interest for some emerging open source platform as the FreeWatt that has been developed by the Scuola Superiore Sant'Anna di Pisa in the framework of an H20 project funded by the European Commission. But there is still a huge lack of competencies, and most of the respondents really stress the fact that they would be willing to adopt this kind of tool, or at least to use this kind of tools. But in order to do that, they would really stress the need for capacity building activities. While actually, as far as I know, the Scuola Superiore Sant'Anna di Pisa, always in collaboration with UNESCO EHP, already delivered a course on groundwater modeling in South Africa, in Johannesburg, and few other initiatives are under discussion in a moment in Nairobi, in Kenya, and in Western Africa. Of course, when we speak about digital tools, we speak about a wide range of different tools, few of them being really very basic, spreadsheets, GIS, that they are basically the most used one. When we come to groundwater flow and transport model, unfortunately, we realize that there is generally speaking, there is a use which is generally in the framework of research analysis, and the applications focused on groundwater management, particularly in transboundary river basin, is still very, very limited. We also noticed a huge discrepancy in terms of kind of applications or publications in between North Africa, where the most of the articles published on peer reviews journals have been reported, and generally speaking, relatively few ones in sub-Saharan Africa, except for a few countries that include, of course, among the others, the South Africa with the famous crisis of Cape Town, and many issues related to the aquifers in the Orange River Basin and the Okavango in the Limpopo as well. So I would say that generally speaking, it was also noted that the capabilities of people involving in developing this kind of models is sometimes relatively limited in terms of programming. But what, at least myself, I was just a bit astonished. There was an interesting trending using quite advanced programming tools as C, C++, further to Python and more established tools. And of course, a huge interest in adopting further to RJS among the GIS platforms, also open source platform as QGIS. So I think that it's all on my side. Let me see if there was any other key message, but yeah, that I would really close my my talk, stressing once more the HCD component, which is a major focus of UNESCO EHP, and which has played a major role in large-scale projects as the East Water 2, where a detailed assessment of specific needs at country scale, as well as assessment at transboundary river basins have been conducted, including further to the basin that I already mentioned, the Niger River Basin, and a few discussions that are still ongoing, focused on the Nile River Basin at a larger scale, that going beyond the Blue Nile and the Lake Victoria areas. That's all. Thank you for your attention.
Thank you very much, Anzio, and thank you again for filling in on short notice with an excellent presentation. As a university professor, I particularly am aware of your comments of capacity building and the sometimes lack of expertise and the need for that to increase. There is a lot of expertise out there, but the number of people who can do this modeling is important. And the data scarcity you mentioned and the financial resources to support modeling is always a crucial thing in this region. So thank you very much. I myself am working in the Niger River Basin, and your comments strike very close to home. So thank you again for a very good presentation.
Thank you.
Our next speaker, our final speaker before we have questions and answers, is Professor Marc Leblanc. Marc is professor at Avignon University, and Marc's topic this morning is recent advances with the integrated hydrological model of the Stampriet transboundary system. And so the floor is yours, Professor.
Thank you, Chairman, Professor Creamer. I also want to thank the UNESCO IHP and all the colleagues for organizing this very large conference. I will present the recent developments that has occurred in the last couple of years with the model of the Stampriet transboundary aquifer. So you're probably aware of this, but the Stampriet transboundary aquifer is one of the three pilot studies for the UNESCO GGRETA project. I want to start by acknowledging all the contributors to this work and the slides that you're going to see next. This is really teamwork, and I feel very lucky and privileged, to be in such a nice group. So I here want to also give a special thanks to the colleagues in Botswana, Namibia, South Africa, and the UNESCO staff, of course. Just a few words about the Stampriet transboundary aquifer. You might have heard about this system before in the conference. There was Professor Canavato just earlier on in a previous session this afternoon, who was presenting also this system. But just in case, so it's a transboundary aquifer that is shared between three countries in Southern Africa, so Namibia, Botswana, and South Africa. Groundwater is the only water resource in this arid region. We have three main aquifers: the Kalahari, which is an unconfined aquifer, the Aob, and the Nosob aquifers that are artesians. The modeling objectives for our study, well, first we want, through the modeling, we want to gain a better scientific understanding of the basin. We then would like to be able to use the groundwater model to quantify the water resources that are available, and perhaps even try to quantify a sustainable yield. We would like to be able to use the model to simulate future scenarios, such as perhaps an increase in pumping, the development of some mines, and also the impact of future climate change. And finally, one of the new sort of objective here that wasn't there at the start of the project is to try to move towards a common modeling platform. So I will be talking about this a little bit later on, but we'd like to move on from an isolated model to more of a shared platform. Okay, so the first step in setting up the groundwater model for the STAS was to look at the hydrostratigraphy of the basin. Previous to our study, there's been, of course, various studies that were conducted in the basin. But one of the issues we found that sometimes they adopted different nomenclatures. So one of our first steps was, of course, to harmonize all the hydrostratigraphic units across the STAS. And this is what you see here in this very nice table there on the right, which is the result of the work by a PhD student, Irene Kinotti, who is about to complete her PhD very soon. What we found, thanks to Irene's work, is that the STAS should not be regarded as an isolated basin, but rather should be really considered as a sub-basin only of the much larger Kalahari-Karo basin, okay, which you have here in sort of pale orange on the computer screen, and the STAS boundary being here in red. So that's one of the first result of this study. This work on the hydrostratigraphy also enabled us to gain a much better understanding of the system geometry. We analyzed more than 300 boreholes, and which you have here mapped on this figure here in green on the left corner. And this work enabled us to then draw cross-sections of the aquifers and the aquitars across the Stampriet Basin, but also all the way through the Kalahari-Karo Basin, which is the cross-section that you have here on the top. That work on the hydrostratigraphy also then enabled us to numerically be able to represent the geometry of the STAS, of the system. So we now have a very good numerical model of the 3D geometry of the system. We are then able to, without any modeling, to give first estimates of the groundwater reserves that are stored in the three aquifers. And we have input data, of course, for the numerical model to define the grids of the aquifers and the aquitars. The second step of our study was to look at environmental traces and how they could help us to define the conceptual or refine the conceptual model for the system there. So we did not collect, unfortunately, any new data, but we compiled previous data that were collected during many studies. And this is the table that you see here on the right-hand side that is a summary of all the data that was available in the Stempriet. So all this data was put together, mapped, and analyzed. And I'm going to show you some of the main conclusions that are important in terms of setting up the conceptual model for the system. Well, first, what these environmental traces are telling us is that groundwater recharge across the whole basin is very low. We see this because all the groundwater samples that you see here on the graph are all located to the right of the meteorologic water line, and they show a sign of evaporation. And when we actually prolong the origin of this evaporation line there that we see in the groundwater sample, we find that the intersection with the meteorologic water line coincide with the signature of that is a marker of very high rainfall. We have a few samples that was collected in rainfall, and the rainfall isotopic marker or signature that coincides with what we see here in the groundwater samples corresponds to very high rainfall events. So these very high rainfall events, of course, in these arid regions are very rare. And in the last 40 years or so of rainfall data, this is in situ measurement, we've only identified 4 rainfall events above 200 millimeters a month. So 4 rainfall events that, according to the stable isotopes, are able to cause groundwater recharge. What we see also from the environmental traces is that recharge is not homogeneous. Indeed, the tritium and the stable isotope values are showing that we have perhaps some preferential recharge areas that you see here are lighted in blue. I have to say that one of the major drawdown of this environmental tracer study is that we do not have any data there in the areas that you see in white. So we only have data there in that corner there. But already we see quite a very a strong spatial pattern in the distribution of the recharge. A third result is that there's quite strong interaquifer mixing across the aquitards. So I'm going to have to move on a bit quicker now to the rest of the presentation. We then considered what type of groundwater model we should use for the STAS. And we came to the conclusion that because we wanted to simulate the exchanges between the climate, the land surface, and the groundwater, we had to use an integrated hydrological model. So here we chose a model that is a couple of between a land surface model, UZF, and a saturated zone, so a groundwater flow model, which is ModFlow. These integrated hydrological models are great because they allow us to represent all the processes, but they have a major challenge. They set a major challenge for us, which is they require a lot of input data. And as you know, there's not a lot of in situ data that's available in the STAS. So we then had the idea to try to look at remote sensing to get as much information as we could from the satellite measurements. And this is what I'm going to present to you in the last few slides. We were indeed able to actually get rainfall data, which is a major driving force of our integrated model, from satellite measurements. You have on the screen the evolution of rainfall from 2000 to 2021, so very recent and updated information. And what I was going to say is that we also have, of course, here you have a graph, but we also have this information in terms of a spatial distribution of the rainfall. So we have maps, time series of maps. Another major driving force of the integrated model of the STAS is the evapotranspiration. Most of the groundwater is actually leaving the system through evapotranspiration. So we actually were able to implement evapotranspiration that is estimated from satellite measurements directly into the integrated model of the STAS. We're also able now to test various products. There's not one, but several products that are available on evapotranspiration. So we're able to test the uncertainty linked to the many products that are available. We got very enthusiastic when we saw that we can actually also derive some of the soil parameters from the satellite measurement. There's a recent publication that was released, I think, in Nature this year, and we were able to actually use some of this information and show that the satellite measurement can provide us some information for the land surface model that requires some hydraulic parameters for the unsaturated zone. One of the last piece of information that we were able to gain from the satellite is the total water storage. And we're very happy about this because our model, because it's integrated land surface and groundwater, it actually does simulate total water storage. So we're then able to compare the simulation of our model with an independent product there. And by the way, you see that unlike the Guarani aquifer, which was presented at the start of this session, we can see that for the STAS, the Stampriat aquifer, we see an increasing trend through the since the start of the year 2000. I want just briefly, before I conclude, I want to show you some of the preliminary results that we get from this integrated model. For us, this is very exciting information, but because we're able to actually plot all the very detailed fluxes that are exchanged between the climate and the groundwater system. So here on the screen, you see in blue the effective rainfall, but more importantly, you see the evapotranspiration from the groundwater, from the unsaturated zone, and then you see gross recharge and net recharge, which is actually negative most of the time in this arid region. Perhaps a last slide, just to let you know that we're trying now to move from a standalone groundwater model that is installed on a local machine to something that can actually be truly shared between all the three countries at the same time. So we're looking perhaps at maybe a cloud-based groundwater model. I think over time now, so I just want to finish by thanking again all the institutions and the countries involved in this project. Thank you very much for your attention.
Thank you very much, Professor LeBlanc. I followed your work for many years in southwestern Niger, for example, your work with Favreau and others on how the change in land use changes recharge. You've done excellent work for many years, and your integrated hydrogeological model that you put forward here is very, very timely. Thank you very much for your presentation. We have time now for some questions. If you have questions for the speakers, I would invite you to put them in the Q&A box. We do have some already. I have one quick question for Professor LeBlanc. You mentioned GRACE satellite data. GRACE has a very poor resolution as far as 1 degree or so. Was that difficult to work with, the lack of resolution of the satellite data if you use GRACE?
No, it's actually, it was fine in our case because the STAS is large enough. So it's over 100,000 square kilometers. We also, with the GRACE data, we can look at the whole Kalahari-Karo basin, which is of interest, to us, so that we don't look at the STAS just in isolation, but we look at the whole geological basin. So we didn't find that it was a limitation in that case. But certainly, if you want to look at a much smaller aquifer system, then that's an issue, yes.
In looking at the questions here, I see someone had the exact same question that I had. But there's a follow-up question for you, Mark. Why could you not use the SWOT model instead of using ModFlow interface to the unsaturated one?
I guess we could have used SWOT, but so far we're pretty happy with the choice of UZF and ModFlow. I must say that there's not a lot of irrigation that is taking place in the Stamford Basin. So that's probably why we didn't go for SWOT, which I think is perhaps more suitable for irrigated areas.
Thank you very much for that. Our next question, I think, is for Christian Navarez. Thanks for your talk. In order to reduce seawater intrusion in the coastal aquifer between Peru and Chile, I think it is better that you can prepare a contract relevant to this aquifer where all the stakeholders will collaborate, including the farmers, and agree on an optimal water management as a result for modeling, a modeling study and monitoring in the future, so you can guarantee the sustainable groundwater management in this coastal aquifer. Would you like to respond to that, Christian?
Yes, thanks. I think it's a good proposal. In this work, my objective was only represent the aquifer and its behavior, but I think this study case require a lot of work with all the stakeholders, but this is, as I mentioned, future work that can be developed in the future for our research group or for other persons, other people.
Thank you very much. The next question, I think, is for Claude Swaplane. Define the phreatic head numerically is an exact solution than the analytical solutions where we have to miss seepage phase. Can you show drawdown graphs and produce seepage phase and rate of withdrawal
I don't think it's a question for me, David.
Okay.
Sorry, it's dealing between Mr. Larabi, I think, and the seawater intrusion problem. I am not talking about that.
Okay, Christian, you want to take it?
In what answer question?
Well, I'll open it up to all the speakers. Define the phreatic head numerically is an exact solution than the analytical solutions, where we have to miss seepage phase. Can you show the drawdown graphs and produce seepage phase and rate of withdrawal? This is from Anad Verdhen. I guess there's no response from our panel. I'm not sure the question is fully understood. It would probably be better, we have a platform for asking questions, and you could specify the speaker that you would like to address that question to.
I think it's better.
Yeah. So Arnaud, if you could do that after the session, that would be great. I guess some of the questions already have been answered.
Yes.
Professor Rodriguez has written answers to some of the questions, but it might be a good idea to go through some of the questions. Could you just mention some of your answers about the cell size that were asked to you? And there's a question about the annual rainfall in the coastal zones. I guess that would be for several of the speakers here. So yes, could you address some of those questions, Dr. Rodriguez?
Yes, of course. I'm sorry I went ahead and answered online. There were two main questions. First, a suggestion to improve the value of the residue. Of course, I fully agree with that. Our average is 27 meters, which is kind of a high. If you think about on a point of view. But the quality of the level data in some places is not good. And the biggest residues were concentrated on pumping areas. So that's a critical issue there. So, but certainly there's much room for improvement. We need more level data. We don't have updated level data. So we hope to improve our results. The second question was about the refinement of the mesh. I just showed the average element size. Of course, when there is pumping, when there are geological structures, we refine the mesh. The size is not regular all across the modeling area. So it's finer where we have pumping and huge hydraulic gradients, and it's coarser where we have less data and no so much differences in hydraulic gradients. And there was another question about the software that I just connect with the attendee that asked me that, and I'm not sure there was another question.
Well, there's one final question. I'll just direct it to everyone to answer. I think
I had another question, but I don't know how to write it. It was for Professor LeBlanc. After that, if I'm able to make my question.
Okay, go ahead.
Well, I was interested in why you have an opposite trend in Africa regarding to an increase in groundwater storage. What is the source of that? Is more recharge when on the other side you showed very limited amount of extreme events. So what was the possible cause of that?
Thank you. I don't want to spoil the work of the PhD student there. She's about to release a paper, I think, on this shortly. But just to give you a hint, we found that this increase in groundwater storage is linked to a trend in rainfall. Okay, especially north of the Stas, there's a substantial increase in rainfall in the last 10 to 15 years.
One final question for everyone. There was a question that some of the modeling softwares are helpful but not available in developing countries. This question is like Nigeria. Can the software be shared? Can we have better strategies? I think Enzio in his talk mentioned the financial constraints to maintain models. Do people want to talk about that very real problem in some developing countries and not having the people on the ground able to use that and capacity building for those people in those places?
Yeah, well, thank you for for the question. That's clear that the financial issues is on the top of the agenda in most countries, in developing countries particularly. Also, if there is an increasing trend towards investigating alternative options of self-financing. And this is, I think, a huge topic under discussion at the level of the African Union and the African Minister Council on water as well. Overall, I'd say that the number, this is well known, that the number of scientists in Africa is relatively limited if we compare to United States, Europe, or also other countries in the Far East. And this has a further impact on the availability of expertise. And I would also mention, which is a quite interesting topic, that most of the time we speak about migration. Most of the time, migration is not only a migration from underdeveloped to developed countries, but it's also a migration, an internal migration. And this internal migration is not necessarily a physical migration. It's most of the time also a migration from one field to another one. And most of the time, water field is not that attractive from the economical point of view. So people, this is also a finding of current research, people having specific capabilities in the IT sector, they tend to migrate from the water sector to other sectors that are more relevant from the financial point of view. So I think that this is another interesting issue to take into account.
I think that we're running out of time. Thank you, Enzio. I wanted to thank all the speakers for really wonderful presentations from all around the world. I think you've demonstrated concrete ways of analysis of aquifer challenges to inform proper management of these transboundary aquifers and to set the stage for future accords and agreements between partners, countries between places. I would like to thank all the participants and the organizers from UNESCO who put this together. If you could please join with me in thanking the speakers for this excellent session. Thank you very much.
Thank you.
Pleasure.
Thank you very much indeed.
Thank you, everybody. Thank you, David Krimer, for this last word. And yes, it was very interesting. And really, thank you all your participants. And I hope, and the attendees, of course, translators, they was here all the day, and the technical support, UNESCO, IHP colleagues. So I hope to see you tomorrow at 10 o'clock Paris time to keep talking about the same topics. Thank you. Have good evening, good day, or depending where you are. Thank you very much.
Thank you very much.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye. Bye. Thank you.